universe is calling me. It speaks both day and night. It's full of dark and light, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all sings with one voice. It's home. Boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Well, hey there, everybody. Welcome to SkyTour live stream for this wonderful evening. It is the 7th of January, and it is 9:30 East Coast time, 9:36. And I am here with you tonight. Daryl has a night off, and we will be exploring the universe together. I really enjoy doing this, as you all know. So, what we're looking at right now, to start with, we are looking at a beautiful nebula called the Spider Nebula. Now, where is it? Well, I'll show you. We'll just bring up our star map here. And as we center it up, okay, here is the Spider Nebula right here. Now, where is that? Well, this is right in the middle of the constellation of Auriga. Right there. There's Capella and the kids, right? So this is a neat area of the sky, and as we're looking through here, we're sort of waiting for Orion and that whole environment to come on up. So we are in Auriga, which is right about there. It's almost directly overhead. In fact, if we go here, we have our zenith lines on, so you can see that Auriga is not too far from the North Pole right there. We're really there. We're right up there. And if you look at the telescope, you can see that it's kind of leaned over a little bit. Okay, so it's going to rise up above us, and in a little while, it's going to be directly overhead. So we're good. We have a really cool night tonight. And let's do this. And now I'm going to put us here. All right. So the Spider Nebula is a diffuse cluster, and it's also a nebula, hydrogen, ionized hydrogen. So as we've talked about, hydrogen is a single proton and a single electron. And it stands to reason that it's the most plentiful element in the whole universe because of the fact that this particular element is sort of the easiest for nature to create, right? So it has a single proton, an elementary particle, and a single electron, another elementary particle. The proton's a +1 charge, and the electron is a -1 charge. So they attract each other, and so they end up in each other's vicinity, and the electron will move into an orbit, so to speak, around the proton. These days we don't call them orbits, we call them clouds, because the electron, and this is hard to understand, but that gas making that red light you see right there is gas where that electron cloud has been pushed off the atom. So right there, when you see this red light, okay, that's the point where that electron cloud has come back to the atom. Now what happens is stars here, maybe these right here, I don't know, there's stars in here, this young cluster here. This young cluster of stars, as this young cluster of stars, radiates its light out into space, the light is loaded with ultraviolet radiation. That's high frequency light, blue light, okay? And that blue light that you see as part of the star's spectrum moves out in every direction, and that's a very energetic light. In fact, it's so energetic that this is the light that can be absorbed by electrons. And so when you have atoms of hydrogen out in empty space, the electron is receiving this ultraviolet energy, and ultraviolet energy kicks it into a higher cloud, a higher energy level. And in a hydrogen atom, there's only so many discrete shells, as they're called, that you can have. And finally, it gets so much energy that it's free of the atom for a period of time. And with nowhere to go, it starts to collide with other things out there, other particles, and that causes it to lose energy. Just like if two cars bump into each other, they both lose some energy. Well, as the electrons lose energy, they're attracted back into their atom again, and as they come back down in, they give off energy, and that's in the form of light. And in the hydrogen atom's case, that light is red. Now, there's more, these are called transitions. There's more transitions that the hydrogen atom makes, but the predominant one that we see in interstellar space, in a nebula, is this red color that we see here. All right, and that represents an electron dropping from outside the atom down into the atom and cascading down to the level number 2. That's a quantum number 2. So, pretty cool. Now that we've done that, and I've given you that little bit of a crazy lesson, I just want to say hello to Calybos, who was first here. Renee Cruz joined us. Fantasy is with us. Thank you. Jane Murdoch. I know Jane. She's been here. She was here for the Mars party we had. Okay, Papa Tom is here with us. And we have... Who's Sky Tour? Who's that guy? And we have Sam S. Nice to see you. Papa Tom, I said. PG, that's Petita. Okay. Now, I saw someone say, hi, Keith. I think that was Papa Tom. But PG is not P and K. You might have thought that was P and K. That's what I'm thinking, because I didn't see Keith here. If he was, I'd invite him in. Okay. And then we have Marianne Robb. Marianne Robb, of course, is instrumental in bringing all the stuff you see here to you. She is one of the driving forces behind Sky Tour Livestream, along with Tara Diulis and myself. And we have some new driving forces that are out there with us tonight, Calybos being one of them, and Tiffany Echo, which is she's with Calybos. And together, they give away equipment, telescope equipment, and they've chosen SkyTour Livestream and our streams as their official designated hub for giving away equipment. So stick with us, because we'll see if there's going to be a giveaway. And it really becomes a spontaneous thing. And when it happens, it happens. Just ask Julie from the last stream and ask JSCO77. JSCO won a whole telescope from us, okay, from this giveaway. And Julie won a pair of binoculars from Celestron, the Cometron 7x50s. And these are just beautiful binoculars. And it gives you a chance to look up in the sky with eyes other than your own. And this is something that I think everybody should have a chance to do, you know. So let me continue saying hello. Gary Hendrick is here. Hello, Gary. Nice to see you. I haven't seen you before, but maybe you've been here. Randy Harris. I know that guy. Hi, Randy. How are you? Oh, he says he's got it on the big screen. Whoa, I should hide. When you're on the big screen at the Harris house, look out. Okay. And Eric is here. Eric's Automotive Diagnostics and Repair. How you doing, Eric? I hope business is good. Let us know. C&D Boy, my buddy. How you doing, man? And KB is with us. First time. Hey. I am so happy that you're here. Thank you so much. If you haven't subscribed, please do subscribe. Join us, you know, and if you're of a mind to, you can actually join our Patreon. You know, if you become a Patreon member, you actually get benefits of getting some of our finished imagery in a highly processed manner, worth framing and literally blowing up to gigantic proportions. You could do anything you want with it, and we'll help you with that if you want to do that. Also, we're going to be instituting, for those folks that want to join us at a higher tier level, then we will be instituting a swag giveaway. If you're committed at a high level, what we're going to do is we have lots and lots of swag. If you want to know where that is, you can go see what we've got, because all you have to do is go visit our store. And you'll say, wait a minute, where's your store? Well, our Etsy store is right up there in the upper right-hand corner. Okay, it's called SkyTour Shop on Etsy. See it way up here. Okay, so go, there it is. So go up to SkyTour Shop on Etsy and check out all the products. We have about 50 products up to right now. And some of our wonderful viewers have purchased some of these, okay? And Renee has, Cindy has. They've received these beautiful things. And I have to tell you, I'm blown away by just how incredible these things look. I'm amazed. But then again, right, we're out in the Arizona desert. I'm not. I'm in Connecticut. I'm 2,500 miles away from this telescope. And so that image of the telescope in the building right there is 2,500 miles away. And I'm running it remotely from Connecticut. Now, how do I do all that? That's actually worth a stream or two. It took me a year of working out the details and working out the methodologies. But once I did, this is beautiful. It's coming out beautiful. Look at it. Once I did, I was able to run it from far away. I've consulted with Avi Loeb's Galileo project team, and hopefully they'll have me do some work with them as well. I've worked with Avi on a few programs, and it's really cool what he's trying to do with the Galileo project. And, you know, Calybos, who's here, he's with SpaceX. You know, we have very high-end people with us, okay? Another one is, you know, Fritz Zwicky was a famous astronomer, a Swiss astronomer. And the Zwicky Transient Facility is actually a telescope, robotic telescope in Mount Palomar that is actually searching for near-Earth objects that could pose a danger to us. It's found many of them, along with comets and other things. And Fritz Zwicky's daughter, Barbarina, has been in our streams and comes back every now and then. So we attract quite a high clientele at times, so it's really cool. But you'll find that I treat everybody the same way. I'm not moved by their status, okay? And I think though they prefer it that way as well. But I'm not moved by their status. What I'm moved by is all of you coming here. Look at Sean. Sean gave us $10. Sean, thank you. I believe that's, it goes by the name of Farva. It's nice to see you, man. And, so people join us, and they do super chats if they can't join a Patreon. That's fine, But remember, our service is free. We're doing this for nothing, man. We love doing this. I love doing this. So I think that it's very nice to spend time here and show you the night sky. I almost feel like it's almost like I'm cheating or something, because this is so easy for me to be passionate about this. I guess it helps that I got an astronomy degree. I guess it helps that I decided that the universe would be my home, and so it is. So I really think that you joining us all of you joining us is really cool. I want to say hi to Genghis, who's here. Nice to see you, Genghis Khan. I am very, very pleased. And Sean says he's a chicken farmer from Georgia. Well, that's okay. You know what? It takes all kinds. I'm just a lowly astronomer from Connecticut, right? This is the first time, by the way, this nebula we're looking at, that we've seen it with this particular camera. The camera on this telescope, which you see the telescope right there, the camera is actually, let me just move this up. The camera is actually on the front of the telescope. So the back of the telescope is here, and the front of the telescope is here, and the camera's up in there. It's a little bit different from what people are used to. But what it does is it gives us the ability to take our telescope, which is normally what they call a photographic f8 system. So, the higher the number, the slower the optics, right? Meaning that no, light doesn't travel slower. It's just that with lenses and mirrors, sometimes what will happen is, depending on the optics, the sensitivity of the optics to the light coming in is affected greatly. So we had an f8 telescope, so that's a photographically slow telescope, and just for instance, I worked on a refractor when I was doing work on the parallax program at the big observatory that I worked in. I worked on this refractor, which was like an f20 telescope, very, very slow photographically. And it would take an hour to get something we can get literally in 5 seconds. And that's because the refractor was meant to take pictures of stars, not faint nebulae or anything like that. But naturally, I couldn't help it. I had to take pictures of faint nebulae, because they're there. You've got a 20-inch aperture. And if you go for the wrong object with the optics of a particular kind, then it's not going to be very exciting. So... so we're talking about, you got to use the optics in the way that they're meant. And these optics went from f8 down to f2. And we did that by, again, moving the camera up into the nose of the telescope. And now we have this gigantic optical system which is pulling in the light from millions of light years away when we look at some of the galaxies, or thousands of light years away here when we look at the Spider Nebula, And I want to just take a moment to say to Calybos. Calybos says he says about getting about 2 hours before dawn, nice and crisp air, and depending where you're located, gorgeous skies. That's true. I mean, there's nothing like getting up and seeing a beautiful blue sky. Blue is my color. I see a blue sky and I'm energized for the day. We just had a major snowstorm, okay? And I've got like 15 inches of snow outside the bunker here. And it's really a lot of snow, and it's not pleasant at all. But it is what it is, right? But it's clearing now. It's clear out there, 2,500 miles away. So this makes me feel good. I'm energized. It's like, energized, Scotty. Scotty, energized. I said it. And then up I go, right? And this music is perfect for that. My energized music. James Dugan's with us. How you doing, James? Daisy and Zoe Amethyst are here. How you doing? I haven't heard from Lane in a while, Daisy and Zoe. I'd like to know where Lane is and how she's doing. Love to hear. As I said, Daryl's got the night off tonight. He actually wasn't feeling very well. He was under the weather. And so we were supposed to do our radio show tonight too, from 6 to 8. But unfortunately, Tara couldn't be with me. Daryl couldn't be with me, and I didn't have time to write segments for the rest of them. But you can always catch me now every 2 weeks on Night Dreams Radio. Okay, Night Dreams Talk Radio with Gary Anderson, and I'm on, like, this past Friday. I was supposed to come on for like a 15-minute bit, and I was on for over an hour. And Gary and I talk about astronomy things that are cool in the news. This past week, we talked about Apophis, the asteroid that people thought was going to strike us, and it did not in the past, and it will not in the future. And we're safe for quite a few years from that one, so we shouldn't have anything to worry about. But we have almost 33,000 objects on the near-Earth object list, and of those, 19,000 are on the risk table, the Sentry risk table, which says these are things that could strike us someday, maybe, until we refine their orbits and see if they're really going to come close. And then, of those, 19 of them are asteroids that we might want to be concerned with in the nearer term. And by near term, I mean 2082. Okay. So clearly, there's a lot of threats out there, but we are trying to monitor them. The Goldstone Deep Space Array monitors these. Things like the James Webb don't do a good job of that, okay? But the Goldstone Array can do it. All right, the Zwicky Transient Facility can find these as well. I want to say hi to Marco, who's here. Hi there. And Dean Bostador, how you doing, man? Okay, we're done with the Spider Nebula. Look at that. That is really pretty. And let's save this, okay? And when we hit save, you'll see a green bar appear. That's an astronomical format file called a FITS, but then we're going to save it just like you see it here. And this is the one you can download. You can download them both for free, incidentally. Now what I'll do is I'm going to actually bring up a system to identify this object, and when I identify this, it's going to tell us what this object is. There we are. Okay, it gives us the information, the stars around it. Okay, it's an ionized H2 region. It's called IC0417. That's Index Catalog 417 object. And we'll save this too, so you have this in the directory as well. And what this is good for is it will just give you an idea of what it was we were looking at if you want to know. All right, so this is out there, and it'll be out there in the annotations. And if we look at what you get, this is what you get. See, it even recognizes this over here. Okay, so that's what you'll see in the directory. Isn't that beautiful, though? That is just beautiful. Wow. Okay, so that's the Spider Nebula. Andy Lino, how you doing? Andy asks if I'm using a hyperstar. Yes, I am. This system uses a hyperstar. We've taken our F8 system, made it an F2, and we're using a camera that is specifically tuned to this. Now, our telescope here is a Meade telescope, M-E-A-D-E, Meade. And this Meade that we have, and this isn't a lie, this is the only telescope on Earth that's been modified to use this system. No other Meade has been converted to this except ours, so we're the only one on the planet. That makes us rather unique, and we get unique views as well. Three Beards is with us. How you doing, Three Beards? What's up? Three Beards asks, what are your thoughts on the research claim that Kamo'oalewa, maybe a piece broke off of the moon? Oh, yeah, actually, that's a very good... Thank you, Three Beards, for reminding me. There's a little asteroid that's been following us around, kind of in an odd orbit. And it turned out that it's a second moon that the Earth has. And this second moon is in a very strange orbit. It's perturbed by a bunch of things, and it's actually not going to last forever. It's going to eventually work its way away from us. But this object could be, and this is what the research is showing, this object could be a remnant of when the moon formed. Now, when the moon formed, well, who knows exactly what happened, but one of the things that they thought about was that maybe the moon was formed when a Mars-sized body hit an early Earth. And I've simulated that in the computer modeling that I've done, and you see that it makes many fragments that break off. Many of those fragments will coalesce with each other. Some seem to go away, and then others form the big moon. Well, the ones that go away might be this Kamo'oalewa. So, very interesting possibility. Possibility. So I think that Three Beards, who is part of Three Beards podcast, he actually said something that I have forgotten about that I wanted to talk about. So thank you, Three Beards. All right, we're going to get out of here now. Yeah. There we go. All right, and now we're going to hop out of here. Looks to me like let me just I'm just gonna close this and open it again. It'll be right back. The only reason we can actually do this is because we have Starlink. Okay, so this is our view right now, and so let's get this come in. Let's do that. There we go. All right, so this is our low light shot. This is like a finder. Okay, so if we come back down to here, all right, you'll see that within Origo we have other things in here as well, and I want to show you something that is nearby. Here it is. That's what I want to go. Okay. Now, when you look in a nebula, okay, you're seeing this beautiful hydrogen gas. And sometimes that hydrogen gas has a beautiful cluster of stars in it. But other times, we don't see that. And there's a reason that we don't see that sometimes. And I will share with you once we get this other object in here, which will be in here just there it is. There it is. Beautiful. Beautiful, beautiful. All right, this is called Messier 35. It's a young cluster of stars, or a moderately old cluster of stars. It is a cluster that has another cluster right near it, which I think is pretty cool. So let's see here. Yeah, we're doing that. I just want to... Here we are. Okay, I'm going to get my guiding screen back. There we go. Okay, so right now we're guiding, and I know it's hard to see, and some nights it's hard, but there are numbers here. These numbers are guiding errors, and the telescope's automatically correcting for those because on the back of the telescope is another telescope that's doing just guiding. All right. I want to say to Alicia Vieras. How are you, Alicia? That's great, and I'm glad that you're here. How's Darlene doing? And how is your mom? Her mom is Renee, who bought one of our wonderful travel mugs. Stainless steel travel mug. Okay. So there we go. So let's set this up now that we're guiding pretty well here. We're going to set this up. We'll do a 25-second shot. We don't even need 25 seconds, but I'll do it. Now you notice I'm putting in 25,000 up here. What's that? 25,000 is the milliseconds, okay? Now, for those that don't remember or haven't been here before, I'm going to show you the most important the most important fields in this whole screen. That's the exposure, okay, and this here is the gain, okay. The exposure and the gain are the two most important fields. The gain is how sensitive the sensor is to the light that strikes it, and the exposure is how long that light is allowed to fall on that sensitive sensor, okay. This over here, this whole area on the left, this is our telescope. It's our telescope control system here. All right. Then down here is the telescope computer. This is the telescope out in the building. This is another view of the telescope out in the building. Right here. Okay. This is our main view. And all this over here, this is all our camera control and focusing material. We also have the temperature controls down here, and this gives us all the things that we need to actually accomplish what we do. So wipe that out. All right, so now you have an idea of what we're doing, okay? And I just wanted to, I just say hi to Michael Hedrick. Michael Hedrick, I'm sorry, I forgot to say hi to you. My apology. Okay, so that said, let me start with our 25,000 millisecond exposure here. And here we go. All right. All right, here we go. Waiting for Starlink to come back. It sometimes takes a while. So down here on the lower right, you can see our yellow progress bar. And then what we're going to do is we're going to stack. Now, when I come up with the stack, you're going to see the previous object that we took a picture of. All right. And it's going to be highly blown out because I have this adjustment on it. But this is our beautiful object. Now, you just saw it and it went away because I accidentally cleared it. But we'll do the next one. Now, what's happening is that this cluster, this beautiful cluster, has another cluster near it. But it's a more distant cluster, and we can see in this one image a really cool phenomenon that is in the universe that will make sense to you when I explain it. And some of you may already know it. All right, so let's, did we actually get that exposure, or did it? Oh, yeah, there it is. Okay, so this is Measure 35, and here is another cluster that looks like it's near it. It's not near it. It's actually much further away. Let me color correct this to help you with the color, because it's more important to see the colors as they should be, and that's better. Now, in Measure 35, we see these beautiful blue stars. We also have some red stars in here. They may be in the foreground and Measure 35 behind, or they might be in the cluster, because some clusters hold together. Now, when they're formed in a nebula, the young hot stars, the first thing they do is they start blowing away with their stellar winds. Their outward radiation flow has consequences. It pushes stuff. All right, just like you feel the sun's radiation hitting your face. That's a small force, but on particles in space, it'll move them over time, and so it'll move gas molecules. It'll move dust molecules, and eventually. You'll be left with just a cluster without any nebula from which within which it had formed. See, so in this case, and let's do this. Let's do something really cool. We're going to take away a telescope for a minute. Okay, go full screen, and just to show this, because I want to show you. So if you look at this cluster here, okay, this cluster is the one that I was just talking about, Measure 35 in the constellation of Gemini, okay? And then over to the right, down here, you have another cluster, but it doesn't look the same color as this one, does it? What's with that? This is a cluster that is farther away, and its light looks redder. Now, wait a minute, what's going on with that? Well, first of all, let's go in and take a look here. All right, let's zoom in. Okay. So this is Messier 35 right here, this cluster, and this is NGC 2158. NGC is another catalog for other objects, and this is a new general catalog, NGC. All right, and this cluster right here is around 2,700 light years away. All right, NGC 2158, on the other hand, okay, is a lot further away. All right, and so this cluster being further away means that we're seeing it through more dust in the universe, through more dust between us and the stars that we're seeing. And you say, well, dust? Where's it? What dust? Every time a star dies, it either puffs off its outer layers with some dust and more gas that it was made of. Okay, the dust is created in the outer atmosphere of a star, or during a supernova explosion. These supergiant stars, these red supergiants, will explode, but they're so big that if you put some of these supergiants like where the sun is, it would go out to the orbit of Jupiter. Can you imagine that? So that means that when you have something like that happening, that in the outer atmosphere of these stars that are so big that way out there it's still hot, but it's warm enough, it's cold enough such that you can actually get dust particles forming and molecules, silicate molecules, carbon molecules. And then you can even get ice forming on these dust particles once the supernova occurs and this dust is out into empty space. And if we're lucky tonight, we're going to see some of this dust. Okay, it's incredible. But look at all the stars. Is this not incredible? You know, hey, Sean, thank you so much. Sean says, thank you for always being genuine and humble towards me. Oh, heck, it's not a big deal. I mean, look at this universe. How can anyone not be humbled by this? You know, this is just incredible. You know, this is my playground, you know, and so I want to share it with all of you. You can play on my monkey bars and swing on my swing, you know, this is the universe. So I think that's really cool. So anyway, I see that you said you didn't see Sean's in the chat. Here he is. He's in there. Okay, so let's bring back our stack. Now I have to define stack for you. I know many of you know this, but what happens is we take an exposure of a certain amount of time, okay, for a certain sensitivity of our sensor, like I pointed out up here, and that first one's going to be a little bit rough because it's just one image and all the noise of the sensor, okay, which is cooled to minus 20 degrees right now, by the way. You can see that. You know, in a short moment, you'll see that. Well, that super cooled sensor is actually keeping a lot of noise away so that you don't get a lot of noise. And so let me see if I can. There we go. Okay. So right now down here you can see that it's minus 20 Celsius. Okay. Right there. Right. Now this so what happens is as we take another image, we have the first one, which is a little bit rough, and then the second one we align it with the first, line up all the stars that you see there, and then place it on top of that next one. And then we do it over and over and over, and we make a stack, an image sandwich. And the more data that you stack on top of itself, the more pronounced it becomes. So faint dark lines of dust in the universe become clear. And whereas you might not see them with one shot, you can see them in 20. Okay, so we've got 15 shots here. If you look right there, it says we've got 15 shots, 15 stacked images here. Okay, and we're going to change the name up here, and then I'm going to tell you why we're doing that. Okay, so M35 is the name of this cluster. It's an OC, or an open cluster. All right, and now we'll save it. All right, so the reason I'm changing the name is because I'm saving it. But where am I saving it to? I'm saving it to here. I'm saving it to skytourlive.org. We have up there, you see that? Skytourlive.org at the top, right? Skytourlive.org is our portal into the entire stream. If you go in the portal site on skytourlive.org, up on the left, you'll see SkyTour live stream, which is where you are now. And on the right, you'll see the Patreon. And then you'll see more things you can look at, galleries, and read about our story. We started from nothing. And thanks to Marianne and Tara and other generous folks that have given their time to us, we've gotten to this point, And I want to be the next Bill Nye the Science Guy, and I want to do it without the attitude. I want to do it with the attitude of I love science, and we got to get it out there for everybody to see. And Izabela's here. Hello, Izabela. Good morning to you. She's in Bulgaria, by the way, so that's why we say good morning to her, because she's quite a few hours ahead of us right now. Okay. All right, we did. We're going to do one more. Let one more shot come in here. Isabel, look at this. Measure 35 and 2158, NGC 2158. These are beautiful. Okay, we're going to get our last shot here. You'll see that 19 change to a 20 right there. And yeah, let's make sure it actually didn't get taken out. We have a filter. Actually, we're waiting for the Starlink. Yeah, we got 20. Okay. Yeah, these are all green. All of our images are good. Okay, cool. Incidentally, we get perfect images now, and the reason is because I'm using something called a full width half maximum filter. Wow, what you say? If the star images are beyond a certain diameter or they start to get elongated, we reject them. So you might see red bars in here along the way. Right now we don't, because we're in good shape. Tiffany Echo. Tiffany here in Calybos are the instigators of this wonderful giveaway that they do now and then. And they will tell us at some point in the stream whether they're going to do that, and then we'll know. Right now, we have no idea whether they're going to do that, and we just have to figure it out. All right. Okay, so I want to thank everybody that's here and peeking in. A lot of you are just watching and not working and not taking part in the chat, but I hope that you will, because on nights when we do giveaways, I want you to be able to be in the chat. You also, to get a giveaway, you have to be a member of SkyTour Livestream. And there's no catch there. It's all free, and we don't send out marketing materials. We don't flood your inbox with anything. I hate that stuff, and you do too. So we don't do it. We just want you to be part of our family and help us get recognized, by the YouTube algorithms and the Rumble algorithms and the Facebook and Twitch and Trovo algorithms. So that's what we're doing. James Hyatt's with us. Hey, James, how are you? James says these are the best giveaways I've ever seen. And right now, Calybos is smiling, and Tiffany's going, ooh, I know she is. She's very happy, and they are both very happy about this because they have put their blood, sweat, and tears into making this all happen. So I have no doubt in my mind that they will continue. I'll be at Contact in the Desert coming up. And that's actually, I'm going to be in Arkansas in April at a conference talking, where we'll be talking about advanced mechanisms by which extraterrestrials could travel in the universe. It's a physics at a layman's level, which is kind of hard, but it's okay. It works. Yep. And Juan Felipe Taborda Parra says, Dios creador absoluto de todo. Yeah, that's true. You know, it's true. You could say that God creates everything. You know, and that's probably true. You know, we can't say it's not. And as a science guy, I can't say that it's not. But Izabela is giving us the image address there. You see in the chat. You can also find it by going to skytourlive.org up there, scrolling down to the dark gray area, which is the next section, and where it says I want cool pictures. You click on that and you read the instructions, and it tells you how to get them. But this tells you she's giving you the server directly, which is available to you. All right, let's go to our amazing view here, and let's all right. Okay, I want to show you an incredible supernova remnant, and it's this one right here. It's right in the area, and it's really something that is literally knock your socks off. So what we're going to do is I'm going to just do this, and I'm going to tell the telescope to go to it, to that section of the sky. All right. Now this is our field of view, by the way. Okay, it's 1.5 degrees wide by almost a degree tall. So that's much smaller than what we had before. Okay, and but I will say this: even though it was much smaller than what we had before. Okay. It is a much higher density of pixels that are in our camera, so we actually get a much better view. More pixels are crowded into that same space. Okay, we gotta wait for Starlink. There we go. I see the nebula right here. I just want to come down a little more here. Let's see here. There we go. Tiny bit. Okay, that's good. You can actually see the nebula right here. This is actually an ancient supernova remnant, and I can show you where the neutron star is. Juan Felipe, thank you. Happy to meet you as well. Okay, we're streaming, we're guiding now. This star is called Propus, and it's a red star. Let me give you the details of Propus. Okay, and let's go here first. Okay, there we go. And Propus, this star here, this is Stellarium, by the way. It's free. You can download it. This is a star that's a giant star. It's called It's an M2. That is to say, it's a red star. A low temperature. Remember I talked about those red giants that actually create molecules in their outer atmospheres because they can be so far away from that hot center. I just talked about that. Well, that's what Propus is. Okay, so it's a M2-3A giant. Yeah. All right, so let's go back now that we're here, and let's set up for a beautiful set of exposures. Let's go 25 seconds here, and just don't fool around. Let's go get it. There we go. So what we'll do is we'll come out of our low light view momentarily. We bring up the stack first, and then when we bring up the stack, okay, you can see how much stuff is in there. We're going to get out of here, and we're going to clear the stack. Here we are. And so we should see our first view of this ancient supernova remnant. There it is. Look at that. Wow. That's incredible. Wow. Yeah, and now, remember what I talked about? I said it looks a little grainy. This is one shot. This is what one shot looks like. Look how grainy that is. Who wants that, right? But when you actually add a second one, watch what happens. We're about to do a second one, okay? And watch here. Look at that. All of a sudden, it gets clearer. And as we keep adding to this image, and we keep adding the images together, we're going to find that we're going to get some gorgeous, beautiful, colossally impressive imagery. Let's drop back down to 33% here to show you a little more of it. Look at that. Now as this comes in, you'll see there's some bluish areas around the edges. Okay. So now what's happening is the star that actually exploded to cause this supernova, you can almost see it. It kind of went this way. Boom. Okay. So this side, all right, out here, you can almost see, and I would have to consult the literature, but it almost looks like one side went this way and one side went that way. Okay. And they can do that. Okay. So we may be looking at that. But what happens is the star that was the progenitor, the one that caused this, is a fast-moving star. So this fast-moving star has moved. You might think it might be here in the middle. You might think this is it, okay, because it's right there in the middle, right? But it's not. The star that actually caused it is down here, and it's I think that's it. I think that's the neutron star. And it'll show as a distinct blue color. There it is, right there. You notice how different that star is from all the others? See how blue that is? That right there, that's the neutron star that caused this. And let me just point that out a little more clearly to you. Okay. All right, 1 second here. Let's see if we get this. Okay, I can't get my pointer to come out. That's okay. You saw it. All right, so again, that blue star right there, that is the neutron star that's speeding out of this region, and that's what caused this. That was the original star, and now it's thousands of light years away. So how the heck can we see it? As a matter of fact, let's go see if we can get the distance here. Again, waiting for this to come back. All right, let me just bring it up again. There we go. All right. So, as I said, okay, now this is our neutron star right here inside that box. All right, but when you look, we see that it's far from the center. All right. And the reason it's far from the center is, as I said, because it was moving quite rapidly. And because of this rapid movement, it moved away from where it originally occurred, and it's moving this way. Now that could be toward us, it could be away from us, or it could be directly sideways. Okay. But that's what it looks like. Now you can see some details in here. Now, when supernovae occur, what often happens, all right, when supernovae occur, is that they will synthesize new elements upon the explosion, and that new element production mechanism is a staple for what these do. And when they do this, you'll find very often that they'll create all kinds of elements that are further down in the periodic table. Okay, now this process, it happens one time with the explosion, and then you get secondary effects as the material moves out into space. It collides with other materials, superheating it, causing it to glow sometimes. Now, our neutron star down here could also be responsible for some of this glow. Now, why were we seeing that neutron star as blue as it was? Why were we seeing that when this neutron star right here is thousands of light years away, and it's only the size of Manhattan Island? You heard me right. It's only the size of Manhattan Island. And I got to tell you, for something that small to be visible from that far away, you know that it means that we're looking at an extremely bright object. An object that if you were anywhere near it would fry you and incinerate you from probably light years away. The radiation from this that it's giving off is immense, and it's actually causing this nebula to glow in some parts, and that's many light years from the source. So that's incredible. Yeah, as Calybos says, please remember to hit that like button and share and subscribe. You know, this is the only channel where we give away equipment, and it's the only channel where you have an actual astronomer who's teaching you astronomy. So if you're not careful, you might learn something. I always hated that phrase, but you know what? I hope you enjoy learning. All right, so, okay, first step first, let me just say this. Yes, there's a halo around here. Now, because the telescope is so fast, that round aperture you see right there, okay, that's this round aperture. Those lines are the cables coming out of the camera that's up there in the opening. Okay, so you'll say, why do you do that? Well, because as you can see, they deliver superior results. Let's see what this thing. So let's do this. Give us a little more detail. Look at that. All right, and let's zoom out a little more. Let's color correct it. And now look at this. Look at up here. This is really pretty. Check this out. You can see this little subtle arcs up here from this. As we zoom in up here, you can see these beautiful. This is the leading edge of this maelstrom of hot gas being pushed away from the center of that supernova region. So that's pretty cool. Eric worked in automotive, and he says for the brightness of these neutron stars I was talking about, to try and grasp a little bit more about how these neutron stars must work, he said he's picturing an arc welder but the size of Manhattan. Well, you look at the color of an arc welder, and what color is it? Well, as Eric will tell you, it's blue. Why is it blue? Because it's so hot. And so we see that happening. Now, those arc welders are probably a lot hotter than the surface of the sun, you know? And neutron stars, of course, are as well. They're hotter by several orders of magnitude than an arc welder, too. So they're really interesting. I won't go into the physics of white dwarfs, which are stars that are only about the size of the sun, and when they die, they become white dwarfs. The bigger stars will cause a supernova explosion, and they shrink down to these neutron stars during that process. So it's pretty interesting how it all happens, but man, it is fun. I love learning this stuff. Okay, I am... yeah, I can see there's another nebula up here. I'm just catching a glimpse. Let's go to our all-sky camera, and let's just take a single shot, see what our sky looks like out there. This is bird poop on our domed lens here, our dome cover. This was taken as the sun was still setting. That's west. That's east over there. As you can see, there's the Milky Way, the winter Milky Way. And right here, you can see the Pleiades right there. That's the Pleiades. Okay. This is Aldebaran and the V shape of the Hyades. Here's Orion, Betelgeuse. There you have Bellatrix, Rigel, and Safe. And there's the Orion Nebula right there. And the belt of 3 stars in Orion. Now, the belt points this way down to the eastern horizon, and it points that way to the western horizon. So you can use Orion to give you your directions if you don't know. Okay. Right here you have the W of Cassiopeia. All right. And the W of Cassiopeia, there's some cool things in there. Then you see a fuzzy object right here. That's called the double cluster. It's a really beautiful cluster, 2 clusters right next to each other. They look almost the same. Really, really pretty. And so that's our playground tonight. Okay, this right here, that's Jupiter. Now, our telescope is a wide field telescope. It's not meant for looking at planets. So if we look at planets, they don't look as impressive as they might otherwise look. So I just have to say that up front, you know. And we have looked at planets in the past, you know. Now, so I hope you like this presentation of how we do this. And we have been doing this for several years now. And it's really nice. We have this nice soft night theme going on here. And I'm in my bunker. I've got red lights over me and blue lights behind me. Okay. So this is 26 shots, more than enough for this. Actually has a weird name. It's called the Jellyfish Nebula. Now, what's funny about that is that, and I'm going to call it SNR for Supernova Remnant. What's funny about that is that many of the nebulae have these names, but they don't tell you what they are. The Jellyfish Nebula, okay, it's a dust cloud of gas of hydrogen. Yeah, not exactly. Okay, it's also a supernova remnant. So the way it formed is extremely different from the way a nebula forms. But because it's pushing out this gas and dust here, as it pushes this out, this is like what's called a shock front right here. And that shock front is a leading edge to the pressure that's pushing outward, and where it goes into space, it plows into other stuff in space. See all the filamentary structure in here? As it plows into stuff, some of it gets held behind, some of it goes faster forward. So that snow plowing effect causes it to break up into little tendrils that we see here. There may be electrical charges in here that are actually causing the nebular filaments to be formed. That's a new theory that may be really interesting to dive into and see if it's actually doing that. Okay, Rascally Rabbit, how you doing? So now, if we save this one more time with 30 shots here, right? It's saving as the supernova remnant that it is. And so what we'll do is we will move on to our next object here. Cool. Now, again, it's saved up to our server. Izabela has been a faithful, staunch follower and believer in what we do, and she lives in Bulgaria. And she does all of our tables of contents. She does all of our addresses to show you where things are if you want to just jump to them and check them out. And she's also a very talented artist. She does a lot of really cool video stuff and still imagery. So her work is unparalleled, and she's done some really nice video work for us. You can see our Etsy store ad, actually. If you go to our Etsy store, okay, on our radio show at night, our video that we have up there that she did for our Etsy store is up there. It's really cool, you know. So anyway, there we go. So now we'll get out of this and move on. So let's come back and do our low light view. Let me bring up the live stack again real quick. Now it's going to have the previous image in it that we took. Oh, but if I clear this now, it's probably going to go away. All right, good. Because I got another feature that we added that allows us to do this. It allows us to take the negative of the image. Now, in astronomy, I mentioned this to you guys before, yesterday or the day before when we last streamed. I very often only use the negative images because if you notice, you can see details in here a little clearer. And you can tell, well, you can see what's going on. And if we actually just remove the color and just go into black and white, this is really what I had to look at from the images of the Palomar Sky Survey and the other things that were done. Okay, the color is really cool in the negative, but this is just like a photographic negative, and this allows us to see the extent of some of the tendrils that we haven't seen before. It's just a nice overall effect that allows us to do some good work. Okay, so we're done with this, and so we're gonna get out of here again, and let's go back and bring up our low light finder scope, and let's go see here. All right, let's go back to our wonderful Stellarium view. Our telescope is run by Stellarium and by all these other applications. I got them all working together. This cluster is cute, but not exactly the one I want to show you right now, because as you can see, we have Betelgeuse right here. We have another number of other objects that are making their way up to high enough for us to see. But I'm going to try to look at one other object that we haven't seen before. Well, not with this camera, but I want to show it to you with this camera because it's really cool. And so we're going to do that. Let me just get out of this a bit. I think it's right here. There it is. This is an area of the sky called the Casper the Friendly Ghost, and it's at 40 degrees above, and you know it might be high enough for us to look at. The telescope's probably already there because there we go. Yeah, see, it's already going there. Yeah, there it is, right there. So we'll move this over, and you'll get to see it. This is really neat. This is our amazing Casper the Friendly Ghost Nebula, and it sits right next to an ancient supernova remnant that we see. It's very cool. ERRT Radio is here. Hello, Ronald. Nice to see you. Judy M. Good to see you. Yep. Okay, so we're going to go right there. You'll see that there's another nebula right here around this star as well. Here we go. Now we're at 39%. Let's go. Let's bring this magnification down a little bit. Go to 20. And the reason is so you can see the whole frame. All right, just a second. One of the things that happens too in the desert is after sunset, we'll often get winds. And you'll see the winds in the live shot by the stars getting suddenly elongated for a moment, and then they come back. And we just saw a little bit of that. So we have some wind out there, but it doesn't matter. We can still get beautiful shots. I'm going to drop us down. I'll keep this in the view and drop us down because there's this beautiful dark nebula right down here. Nebula made of dust from many of these supernovae, from these big red giants I've been talking about all night. And I'm going to show you what it looks like in the setting of the universe. Okay, that's good. All right. So come back here and I don't know why I did that. All right, let me just. There we go. Okay. And okay, we're seeing numbers here, so we're guiding. You notice that you saw that little shift. That wasn't the guider. That was actually the wind out there. So I would imagine as we take this picture that some of them will not work. But we'll still try it. We'll get them overall. Okay, we're going to do a 25-second exposure again, which is 25,000 milliseconds. Okay. We'll bring up our live stack right now and remove the last object if it hasn't been taken out already. Okay, we'll get rid of it. All right. And now you're going to see something a little different. You're not going to see a cluster of stars. You're going to see a cloud of gas that's illuminated by a star, and you're also going to see dark dust. And that's if the oh, it came in good. Okay, let's get rid of this additive processing. There you go. So now you'll see this dusty area. Look at this. This here is actually dark dust in front of the nebula behind. Okay, you'll notice the nebula is not red. But wait, Mark, you said nebulae are red. Yeah, they are when you're actually looking at a nebula that was from ionization of hydrogen. But when you're looking at a nebula that was created by a star's blue light being scattered by dust, then you see a blue nebula. And in astronomy, we call it a reflection nebula. It's not. It's reflecting in a sense, but what's happening is it's taking only the blue light and reflecting it. Okay, it's not taking the rest of the light because it has to do with the tiny, tiny dust grains and their size. At that size, the blue light is more easily reflected. And the actual term is scattered. This is a scattering nebula. So, and for the reason that this is blue is because of that dark dust that's scattering the blue light from the star. The molecules in our atmosphere scatter the blue light from the sun. And during the day, we see just blue every direction. Every direction. So, this is a case where this blue light is scattered in all directions, and the red light and the orange and yellow light is allowed to come through. So, really cool. Okay, I'm going to look at the chat here and my separate chat because I want to see where we are. Calybos, are we doing a giveaway tonight? This is the official reckoning. Want to make sure that we're doing a giveaway so I can tell people about it. If so, let me know the particulars in our private chat that we talk in, and I will announce. Okay, so check this out. Look at this beautiful image. Look at how astronomical this is. I'm going to give us a little more proper color. You'll notice now there's a different color in this view. We see the black of space. We see the color of the stars. We see the color of this reflection nebula. But we also see this dust. And look, it's not black. What color is it? It's brown. Brown. That is impressive. That is impressive. So I think that's pretty cool. Now that brown dust is because we're looking at silicas and carbon atoms that are literally forming molecules. And in those molecules, They are a perfect catalyst for attracting ice of all kinds. You have methane ices, carbon dioxide, formaldehyde, ammonia ice, water ice, of course. And through interactions with the ultraviolet light from stars in the region, we also are getting more effects and more objects, more molecule compounds that are coming off of those dust grains. It's really pretty impressive. All right, this is the Casper, the Friendly Ghost Nebula. This actually is a really nice image tonight. All right. So let me... Let's write a message here. All right. Okay, so the winning number for tonight will win you a pair of Celestron Cometron 7x50 binoculars. Now the universe can become your playground as well. You sit outside and you look at the sky and you see it like never before with these beautiful binoculars. So now that we know they're given away. I see people put your guesses. You're going to be entering a number between 1 and 1,000, and that will give you your entry. You only have one entry, and to win, you must be a subscriber. So that means you have to be a subscriber to SkyTour Livestream. That's not a big deal, guys. Let's be clear, because we don't charge you anything. If you want to support us in the Patreon, you can. If you want to support us by doing a super chat, you can. But you don't have to. So you feel free to do as much or as little as you want. But notice this beautiful brown dust here. Isn't that incredible? This is, and to see where this is actually an area that's just to the left, okay, of Alnitak, which is in Orion. And Alnitak has the Horsehead Nebula and the Flame Nebula, Casper the Friendly Ghost. And to the upper left here, which is not really that visible because our smaller field of view here, you can just barely see. Let me just see if I can pull this up a little. Okay, see this red up here? That's not an artifact. That's the remnant of the ancient supernova that occurred here, part of a loop of gas that goes many light years called Barnard's Loop. And it goes all the way around Orion. You just don't see it. And it's mostly on the left side of Orion. But this is the Casper the Friendly Ghost Nebula like never before. Look at these beautiful, intricate details. You know, this is the first time with this camera, okay? With the previous camera we had here, many of these subtle, tiny details eluded us. We couldn't see those. But now we can. This is a perfect song for this, too. This is Gymnopedia. How beautiful. In here, you notice there's a subtle secondary cloud that's being illuminated by the stars in here. Now, why aren't we seeing red? Well, there's some red emission nebula here from the hydrogen, but most of it is this dark dust silhouetted by the stars, okay? And we see very, very subtle details in here. But in this particular region, there may not be a lot of hydrogen. There might be a lot of dust. However, down here, you can see that there is a reddish cloud. So, and then here, we have subtle red in here. So clearly throughout this region, there is hydrogen emission going on, all right? And as we said before, we know that the top left here begins that band of very, very diffuse ionized hydrogen that's part of that famous Barnard's Loop. Now, the reason this is on the right side is to show the other details in here. A lot of detail. This is very, very amazing. Let's try to pump that up artificially to kind of show you what's really there. There you go. Now you can see, now we're not going to keep this up here, but just to show you the intricacy of this material that streams down here, okay, and to see it up here, it's incredible. And there's more stuff here. Lots of red emission nebula, diffuse stuff. Yep, really cool. So we'll get rid of that, and we'll just play with our other levels over here that I think are going to be better to use for this. Well, first let's see where it wants to be. Okay, that's where it wants to be. And let's color correct. Okay, we're pretty accurate here. This brown color, brownish color with little red mixed in, very accurate for what it looks like here. Very accurate. Okay. I'm reading on our giveaway tonight. I'm just reading some notes here from Calybos and Tiffany. Remember, guys, if you're here watching and you haven't entered a guess of a number between 0 or 1 and 1,000, that will give you an entry into the contest to win a pair of Celestron Cometron 7x50 binoculars. So far, we've given away an entire Celestron telescope, a pair of Celestron binoculars, and we're doing another pair of Celestron binoculars tonight. So that's courtesy of Calybos and Tiffany. Lynn Bible says 500. That's her entry. Lynn, are you a subscribed member of SkyTour Livestream? Please go subscribe, and then your guess will be counted. It's nice to see new faces out here tonight. Let's back out of this a little bit more now. Come back in. Look at that. This is actually quite incredible. You know what I'm going to do? We're going to drop this down, and we're going to get rid of the telescope for a bit, and let's go full screen to enjoy the arrival of the Casper the Friendly Ghost Nebula. Wow. A lot of subtlety in the clouds up here. It looks really nice. Really nice. More detail in there that we haven't seen before. Let's do this. Let's pop this up a little bit. Renee Barron says 755. Look at that detail in there. See, this is all stuff that will come out as we process. Okay. I'm just going to wait a few more. I'm going to write a message now here. Message received, Calybos and Tiffany. No, we're not sending secret messages with a special, a secret handshake. I'm just trying to help to organize this giveaway tonight, and to do that requires a little communication on the side. Vince Giglio, how are you? Nice to see you. I'm looking at some pretty cool stuff. Sean says, looking at these objects, it looks like celestial beings. I gotta say something funny about that. Not funny, but maybe thought-provoking. Yes, it's interesting because as you look at something like this, we're used to life being on our planet. We're not used to life kind of like in the episode of Star Trek The Next Generation, Encounter at Farpoint, the first episode of that show. Giant being that was part of the planet, but it was a life form trying to just get free, and the Enterprise helped to do that. Well, obviously science fiction, but still, it forces you to think about new ways that life may exist. And I think that's what's incredible about the universe is we learn more and more every day. Look at this beautiful. I actually did some more contrasting here. That is stunning. And you can see this brown dust all throughout this image. You know, this is just like a little bit too much, but it was there just to kind of show that. So we'll pull that back a little bit, drop the contrast down. Okay, this line here, let me have you know, just so you know what these curves are, okay? If you look carefully, you see that there's a red, green, and blue curve in here, and then there's a white curve. That white curve is the average curve, okay? So we want the red, green, and blue curves to kind of line up, all right? If they don't line up, like if I do this, like if I move the red curve, look what happens. The average curve moves with it, and then, of course, the image changes. Go the other direction, and the red curve is over there now, and there's too much red in the image, okay? And the average curve's in the middle, as you see right there, okay? Right there. So now, if we let it color correct, it's going to bring all the curves together, okay? And then we see our properly color balanced image. And the white curve is the average curve. So this dotted line represents our black level. If I bring it way in, okay, most of the data is in this peak. So if we bring it in, we're not going to catch but what's down here in this other area of the curve, okay? Similarly, if we bring this back just the head of the curve, just if we bring it back too far, then we get it's too bright because we're including data that includes additional elements from the atmosphere out there that just make it, even though it's very, very dark, you still have a certain amount of light in the air, and we're trying to get rid of it. So we climb this curve until we're just about at the top, right about there. And then this curve over here, if we pull it way down, you see what it does. Okay, it makes it get dimmer, and sometimes that's desirable, but then you pull it back. As we bring it back, that yellow curve, see the yellow curve right here? It's intersecting more of this data. So right now, the yellow curve right here represents that it's looking at whatever data is under this curve. If we included the data all the way over here, then we would have an extremely bright image. And as we do this, you'll see, okay, that we get now more data, and it's just way too bright. Okay, way too bright. Okay, so there you can see the reds and the blues, but you're also seeing a lot of overblown imagery that isn't helpful to us. So we have a way to automatically pick the best, the happy medium between all of it, and that's this right here. Okay, we've done quite a few frames here. We've done 37 here, and we're going to dock our beautiful stacking algorithm, bring back the telescope now, right? And so there we go. Now, there we go. So we are at 37 images that we have stacked, and we're going to save these now. 38. Okay, we're at saved. Save exactly as seen. So now we've done 3 objects with you. All 3 are up on the server. This one here, as I sit here and count, we are probably going to find ourselves having that image get all the way up there already. And when I say up there, it's leaving the observatory here, right here, leaving this observatory, heading up to the cloud, hitting a satellite, heading up to a cloud, and heading back down. And it's being stored up here on skytourlive.org, right up here. And so it's going to be dropping on skytourlive.org within just a few seconds. So very cool. I have a feeling that you'll enjoy seeing all these images we took tonight. Okay, 40 images. Save one last time. Save exactly as seen. And again, these are all free. Once you go to skytourlive.org, it'll take you right to them, and you can download them right then and there. You know, if you want to support us at the Patreon, then you can get images that are outrageously beautiful, because we process them to make them look fantastic. But there's the Casper the Friendly Ghost. And now we're going to come back to our Finder mode. There we go. Alright, and let's bring us down to, let's say, 25%. Okay, and bring up our planetarium that controls things. Alright, and since we're in the neighborhood, what do you say we go check out the Horsehead? And we'll get to the Orion Nebula after that. Alright, let's actually just go to this location. Alright, so we're going to go to this location. Alright, and that'll take us to where the flame is and the Horsehead are in the same field of view. Here we come. And it looks like we're going to be fine. There's Alnitak right there. You can see the Flame Nebula right there. And just down here is the Horsehead. So let's go down and check it out. You can see the Horsehead right here. There we are. That's good. A little more. Just want to get it down so we can have the Flame Nebula and the Horsehead in the same field of view. This is Sigma Orionis over here. That star is responsible for causing this red glow that you're about to see. Alnitak is energizing this part of the Flame Nebula as well. And we are now guiding. So let's do a 25-second shot here. You notice I'm not doing any like 5-minute shots and things like that. I could, but why would I? Our telescope doesn't need them. You know, we're catching everything right from a 25-second shot. There's very little that is left to see. All right, so let's clear this guy. All right. Curtis Horn is with us. Hey, Curtis, how are you? Curtis is an extremely technical individual with incredible knowledge in a variety of topics, including astronomy. So it's always good to have Curtis with us. PG, I'm sorry I couldn't get to Newburgh, New York for New Year's. It would have been very nice to see you and Woody, but I didn't have a car. I was in the process of getting cars fixed, so it was really a tough time. So we have them all now, but we have one we're still working on. Ball joints, not easy. Okay, it looks like we had, yes, that's what I thought. Okay, so here's a good example. This is a case where 3 exposures we took so far are outside the range. So I'm going to raise the range a little bit. And let's see if we can fall and get another couple of... Yeah, this means that there's some wind out there. And the wind is causing the telescope to move a little bit. And of course, thus we're rejecting our images because they would otherwise just be oblong stars, and we don't want that. Hey Tim F, how you doing? Right. Alright, so I just want to mention, guys, in case you forgot, we are giving away with Calybos and Tiffany another pair of Celestron 7x50 Cometron binoculars. And unfortunately, you have to be a subscriber to our free channel, Sky Tour live stream with Mark D'Antonio. I know that's a whole lot to do, my goodness. But if you do it, you get a guest, and you could win anywhere from a telescope to a night vision system and binoculars. Tonight we're giving away binoculars. Okay, I may have to raise this number just to see what a rating of 9 is for this. You might see a slightly oblong star. Hey Lubo, how are you? Lubo from China is with us. Here we go. Ta-da! You'll notice the stars are a little elongated. But this is what I'm trying to get. I'm trying to grab this image right here. 9.43 is going to be an elongated image. We don't want that. Yeah, so I have to clear this. I want to be able to capture a beautiful shot of this nebula. And the nice thing is, if we wait long enough, it'll come in fine. Fantasy, what's happening? Master Players Radio, what's going on, man? Master Player, if you are a subscriber to SkyTour Livestream, your guess of 698 will count. Cosmic Ray asks about a shorter exposure. It's 25 seconds, so we don't want to go shorter than that. It won't show us anything appreciable. If we can't do 25 seconds, then we won't do it at all. Yes, I could go shorter, but it's not. If the wind's blowing, then however short you make it, it's just be a smaller, elongated object. Hey, we got one. Yeah, see, our stars are nice. See that? A lot going on in this image, and I'd like to unpack it for you. Let me just get rid of this here for a minute. Okay. Here is the famous Rosette Nebula. The Rosette is a region of dark dust that is part of this overall complex. This is sort of like a wall called the Orion Wall. And it's an area where there is a tremendous amount of dust. The Casper, the Friendly Ghost Nebula, is just to the left side of this, remember. So if we go back to our our star map here, there is Casper the Friendly Ghost, and we are here at Alnitak. Okay, so it's in the same relative region. And this relative region that we're at is really interesting because this whole region, all of this throughout this whole area, is just chock full of dust. There is so much dust everywhere we look when we're looking along the galactic disk that it obscures stuff behind it. As an example, see all the stars out here? Where are they here? Why do they seem to vanish here? They vanish because of the fact that we are seeing dust that's obscuring them. And you'll notice that some of the stars are extremely red and tiny. And that's because these stars are embedded in this dust, and their light is being reddened by the dust in the same way and in the same reason that the sun's light is red on the horizon at sunset and sunrise. So we see the regular physics of life on planet Earth throughout the universe. And that's just what we're seeing here. All right. So these halos, again, are from our optical system here that uses this camera at the front end of the telescope. We remove those halos in our processing later. Okay, let's see now. Because of the wind, we took 8 frames and 5 of them were stacked, 3 were ignored. But check this out. This is the Flame Nebula up here. Now you see me looking left and right. I have a big curved screen in front of me. It's a big curve. So I have a left-hand side and a right-hand side. So this is the observatory live feed, and this is the broadcast feed. When I do the broadcast feed, I want to talk to you, so I will look here because the chat's over there too. So let's zoom in on this. Okay, a little too far. So the Flame Nebula is a very fascinating nebula that I used to not give it enough credit because it really turns out that there's a lot going on in here that we just never realized, right? So let me go back to actually here, increase my a noise reduction parameter. There we go. So now, look at the detail in this. Look at this little black thing right here. Let me show you. I'll come up here with you. Look at this little tiny squirrely tendril right here. Look at that. That really cool thing. That's neat. You know, that represents an area where there's a lot of dark dust, and that dark dust is made mostly of carbon and silicon atoms that were the result of supernovae explosions. Similarly here, okay, this stuff is all dark dust made by supernovae explosions. And so, and by the way, when the stars, when I say made, it existed before the supernova, but it was pushed out by the supernova. When a star turns into a red giant and red supergiant, when it goes near the end of its life, it gets so big that, as I said, the outer layers are relatively cool compared to the inside blazing core of that sun that's still doing a little bit of fusion. And those outer layers are cool enough, even though they're too hot for our life, they're cool enough to form molecules. And those molecules could be molecules of carbon-carbon. So you have like 2 carbon atoms that are bonded together. And carbon is really interesting. Carbon has the ability to have 4 connecting points on its atom. Okay, has 4 electrons on the outside shell. Okay, of all the atoms, all the electrons it has, and those 4 electrons can bond with 4 different things. So you can have carbon bonding to carbon. And 3 of those outer electrons can share a bond with another carbon atom. And so you can actually have this rather robust carbon-carbon molecule out there. And this is something that is really visible throughout the universe. When we look throughout the universe, we see this. And the silicon atoms, similar type of thing. So what happens then is when we get an object like the Flame Nebula here, and we get this dark dust in here. Well, that dark dust has these ices on it that I told you about. Ammonia ice, methanol, formaldehyde, carbon dioxide, water, and you might have a silicon core, or a carbon core. And what will happen is when you have a hot star like Alnitak here, which is an O-type star, like one of the hottest and bluest stars you can have in the universe, it's only going to live a few million years, not nearly long enough for planets. When you have that star's radiation striking this dust over here, what happens is the ice begins to just sublimate, and all those particles that froze onto the surface of the dust particles before Alnitak was even here is driven off. All right, and it forms a chemical soup, a primordial soup of planet and star making materials. Star making from the hydrogen gas in here, planet making from the dust in here. So there's many different mechanisms by which you can get this the planetary formation to be undertaken. But this is a primary way. Life is born in the dust, and it's born in the dark. Okay? And so in the dark of the universe, that's where you look. You don't look in the light of the universe. It's too hot here for us. It's too hot here for life in general. The radiation is too powerful to allow carbon atoms to bond together and maintain that bond. It's too hot to allow water molecules, H2O, to stay cohesive. It gets driven off and separated. It's called photodisassociation. And the H2O gets driven off. And when that happens, you're left with hydrogen and oxygen. Okay. Interestingly, hydrogen, as we mentioned, is the most abundant element in the periodic table in the entire universe. Okay, so it's the most abundant element in the universe. So it stands to reason it's number one in our periodic table. And it's not by abundance, but it's just the simplest atom. So the simplest atom can exist easier. However, another atom, which is actually like next to hydrogen, the next most abundant atom is, of course, helium. And helium atoms are atoms that have 2 protons and 2 electrons. So it's a little bit more I should say complex, right? But then you make your way down to carbon, and by the time we get to carbon, okay, now we're looking at eight protons and 8 electrons, and 4 of those 8 are sitting in the outside shell, right? But carbon is the 4th most abundant element in the universe. So hydrogen's number 1, helium's number 2, there's another one that's number 3, and then carbon is number 4. What's number 3? Number 3 is oxygen. Yes, that's right. Oxygen, the thing that carbon life forms need to survive, is the 3rd most abundant element in the entire universe. So with hydrogen out there as the most abundant, and oxygen it's as the 3rd, and then carbon as the 4th, it stands to reason that life is probably going to be based on carbon. And I guess that makes me a carbon bigot, right? I am. I guess I'm a carbon bigot. So that said, Alright, so let's see. I'm going to read a chat now to give my voice a rest for a moment. Hey, Prow, how you doing? Well, good to see you. And let's see who's made some comments here. Fantasy says this region Mark's currently highlighting is amazing to stare at in those binoculars you can win tonight from Calybos. You may not see this in those binoculars, though, because you need a really dark sky sight. You might see a hint of nebulous stars here. You may see a tiny bit here, depending how dark the sky is. But the horse head is actually very difficult to see. You may not see that, but that's cool. Izabela says the flame looks gorgeous. It does. You know, you feel like you can just dive right in and see different layers. So again, with this camera, we see so much more detail that we were not able to see. You know, with the previous camera, it's literally a brand new world for us with this camera. So, everybody likes the Flame Nebula, I guess. It's really cool. Master Etzelman could go negative and zoom on that. Yeah, sure. Why not? I can zoom for this. Zoom this for you. Let's do that. Look at that. Now that is a really, really beautiful shot. Look at that swirl that I talked about before. Look at that. This is stuff that was not visible to us before. Look at that. That is something else. Wow. I find this to be just phenomenal. All right. All right, so there you go, Namaste. There's your zoom on the flame. Now let's go look at the horse head. The horse head has some interesting features too. If we zoom in that, okay, you notice the top of the horse head here has a lighter look. That's because it's dust and it's actually reflecting starlight from nearby. You notice also there's a tiny star right in here. In fact, let me highlight these for you just to show you. Okay, we have a tiny star in the top of the horse head right there. We have one in the main right here. Oops, let me get rid of that. That wasn't a good one. We have one in the main right here. It's right there, a little one. We have one right here. We have one in the nose right here. Little tiny stars. And you'll see filaments in here. Okay, these filaments are the result of dust that is just streaking by and streaking through this area. The nebula continues for some distance, as you can see. This is a tendril sticking out from the big, giant black maelstrom of molecules that are the Orion Molecular Cloud Complex, the Orion, the OMCC, the Orion Molecular Cloud Complex. Amazing, this area. So you stack 25, and you'll notice out here, there's a lot of detail out here. You see wispy structure here. That's probably stellar wind-driven details that are created by Sigma Orion is over here. So that's just really pretty. Just love it. That's really nice. Oh, that's incredible. Wow. Oh, so we're going to call this Flame and Horsehead. And that's going to be an EN emission nebula and a DN dark nebula. And we have these reflection nebulae here we haven't even talked about. But if we zoom in on those, you'll see something interesting here too. There's something for everybody. As we zoom in, you'll see there's some really subtle details in here. Black lines. You got this one here, which is really amazing. And then this star inside this dark dust. And it's actually, let me see if I can bring this up and then bring out some more detail that I'd like to show you. So let's go back into the histogram and let's try to negate some of our noise just to start to show you some of the detail in here. Okay, you can see this really nice sharp-edged cloud here. It's really pretty. And then you've got that nice thing in there. This is like a pocket inside the dark nebula. And this stuff you see here is way out in front, okay? And the other stuff that's all illuminated is back here. So you're seeing it, but you're seeing it really, really... you're seeing it in 2 dimensions, but it's really a 3-dimensional object. We don't even know if the horse head is an object that's flat like that or maybe curled toward us, but we don't see it properly. Can't tell. But isn't that pretty? That's just beautiful. Yeah. Another star nearby is doing the same thing. It's causing the light to be reflected off of the dark dust in here, or scattered to be more proper. All right, so let's back out. Remember, this image you see just like this is available for you to download as soon as I do that. And now it's there. And then I'll save it exactly as seen. And now that PNG file is there. Now, here's the image that's up on the server. This is what you're going to get. There it is. That's the image. Okay? That's the exact image. And this is a big file, okay? In terms of its size, we're looking at, let's see, we get the dimensions. It's like 5,400 by 3,800 or something like that. It's a really big, here it is, 5,496 by 3,672. So 5,500 by about 3,600. That's huge. So that's a really good capture area, and that's a lot of pixels to jam into a smaller field of view, and that gives us all the details that we want to see so much. It's hard to want to leave this, isn't it? Hey Stuffy, what's happening? Nice to see you. Don't forget, we're having a contest tonight. Okay, think of a number between 1 and 1,000. And if you pick the lucky number, you win a pair of Celestron Cometron 7x50 binoculars. So you can go out and look at that beautiful cluster we saw before, the Measure 35. And you can even see NGC 21, was it 58 or 68? The little cluster next to it as well. And Eric asked the question, says, is there a mechanism to concentrate carbon? How would Bennu have higher levels of carbon than every other asteroid? Well, it's not true that Bennu has more carbon than every other asteroid. It has a high proportion of carbon. But asteroids, they will end up with carbon on their surfaces over time, whether they've done that through impacts from other objects. Remember, they've been here for billions of years. A lot happens in 4.6 billion years when our solar system formed. So, and the carbon that we see also is something that is their base chemistry, their base composition too. There's a lot of it because remember, carbon is number 4 in elemental abundance in the universe. Hey there, Goblin. Thanks for your guess. If you could, make sure that you are a subscriber to SkyTour Livestream. So if you are and your guess is the right one, then you win. Okay, let me just check in here. Dan Nicholson, thanks for your guest. Welcome to the stream. Make sure that you guys subscribe to SkyTour Livestream. Join us if you can. I mean, we need your support. Also, keep in mind that we have an Etsy store. There it is up there in the upper right. The Etsy store is called SkyTour Shop, and you can get any of these images that are on some of our fabrics and lamps and sneakers. Yes, you can get sneakers with this image on it, believe it or not. So anyway, you can visit us there to capture that and see if there's something up there you'd like to get for yourself on your desk or whatever. And as always, you can join our Patreon. So please consider supporting us by becoming a Patreon member. We have reasonable tiers. I would like to thank our current patrons: John P., Izabela M., Ollie B., Chief McCyber, Vera C., Ronald T., Martin W., Raymond B., Cindy M., Susan W., Diane H., JSCO 77, and Tiffany Echo. Tiffany Echo, our latest subscriber. Thank you, Tiff. JSCO 77 is the one that won the telescope as well. And so we've got a lot of potential to grow here. So I would hope that you guys would join us and help support us. The Goblin says, just found your stream. Love it. I'm really happy, Goblin. And make sure you subscribe though, okay? Just go hit the join and subscribe. It's all free. There's nothing, no credit cards or any garbage like that. Okay. So there you go. Alicia, yeah, it was like a tongue twister, wasn't it? I can't believe I got it right. See, one thing you guys don't know about me, maybe some of you do, is that it was just a few years ago I had a surgery that went sideways. And when I awoke 5 days later, I was a quadriplegic and profoundly blind. And my first thought was, how will I look through the telescope again? And my second thought was, I'm supposed to do a talk 3 months from now in Los Angeles. How am I going to do this talk in Los Angeles if I am a quadriplegic and blind? So I was in a coma for 5 days, and during that time I was actually wide awake. And no one believes me, even though I've passed on all the conversations that the doctors had with my family saying how I wasn't going to make it, etc. I heard all of it. But I knew I was going to be fine. And that's something that, that's another story. But I ended up getting through this, and I ended up, during the coma, figuring out how to heal my brain. And I have since talked to other people in the country, shown them what I've done, and they have actually healed too. No, I didn't write a book. No, I'm not doing this for money. I want people to just understand that their brains have the most incredible capabilities. So in my case, during the surgery, I had 8 major strokes in the table. Now, one stroke's enough to kill someone. Why I didn't die, I don't know. But my visual center is gone. Yet I have 98% of my sight right now. Okay. I re-engineered it, and I made the neurons reconnect to other places in my brain and double up or shunt the and I can't say I did that consciously, but I just knew how to make the brain make that happen. And I did it through pain. No one wants to feel pain, but when you have pain, the brain is evolved to take you out of the pain, keep the pain away from your body. So what you do is, if you embrace that pain and say, all right, I'm going to go for this pain. I'm going to stare at a screen I can't possibly see. And the images of this screen from this TV shows that the nurse was playing over and over for me are going into my brain and dead ending in a dead visual center. that dead ending caused extreme pain. I ended up with migraines. I passed out from the pain. It was so much that I had to go through for that. But what happened was amazing. And the eye doctor at this particular rehab hospital where I was going to end my life, okay, the eye doctor there couldn't believe how my sight changed from profoundly blind to being able to see in 1 week. And now I say be able to see. I could see some things. I was still working on that. So what I did was I ended up letting my brain reroute neurons by forcing myself to watch a screen I couldn't see and feeling pain. My head was throbbing. As I said, I would pass out. And then the brain said, I can't handle this anymore. I've got to figure out a way around this. And just like that, I suddenly saw shadows. And the brain was saying, in my head, I'm thinking this is how it was. I've seen this before. I know what this is. And that led to me getting all my sight back. And when I had the nurse put a ball in my hand, it felt like burning molten lava, hotter than that B star right there. Okay, it felt to me, and it was like molten lava, and I couldn't stand the pain. It was like you were stabbing me, and I couldn't move. I literally couldn't move. So there it is. I have this ball. What do? I tell her to leave it there, and I really didn't want to. I really, really didn't want to, but I knew that for the brain to work right, for the brain to find the spare parts to repair that connection and get me out of this trouble I was in with this pain, it had to reroute neurons. So the ball in my hand was literally ungodly pain. I passed out many times from that pain. But one time the nurse came in and I had my hand like this with a ball in it. And I literally was just like totally disheveled. I was grimacing in pain. And she said, let me take that out. I go, no, leave it there. And I held it. And then all of a sudden, my hand went like that. And the ball fell out. My brain figured it out. It figured it out. And then from that moment forward, that little motion led to everything else working over time, getting my shoulders back. Same thing with the right hand and the feet and the legs. All that stuff came back because I subjected the brain to the pain. I don't want a pill to make the pain go away. In this particular case, for this particular ailment, the pain is how you heal. And I have surgeons on board with me on this. They believe me 100%. They know because I'm living proof. So that said, if anyone's interested in that side of things, I'd be happy to talk to you about it. I was nominated to do a TED Talk on this, but I haven't yet, and I think it's because with COVID, they're just so behind with their in-person talks that I haven't heard anything. Maybe they don't think it's interesting enough. I don't know. Whatever the case, I know people, around the country that have used this, embracing the pain and fear. Okay, the other aspect, if you don't feel pain, and they healed. They were able to perfectly heal. And so they told me I'd be in the hospital 8 to 10 weeks and then a year of recovery at home. I'd probably only ever see shadows. They didn't think my visual center was ever going to be repairable. And it certainly isn't. However, I was there on June 15th, 2015. And by July 3rd, 2 weeks later, they were sending me home, scratching their heads like, how in the world is this happening? And I told them, well, the reason it's happening is because of what I told you. Everybody has the ability to heal their brain. Okay, we are carbon-based life forms made of that stuff you see in this image. And based on what we are made of, our brain evolved a way to protect the organism from danger. Okay, it's a gift to the universe, in fact, right? Because of the way we evolved. So I really think that when you think about how humans evolved on our planet. This is looking stunning, by the way. Holy cow! When you think about how we evolved here, we literally have backup mechanisms in our bodies to protect us and keep us safe. And the surgeon that operated on me said, you know, you were able to connect with these spare parts that everybody has, and if people can't do it, then how they may never heal. And that just breaks my heart, because I know people can heal. I know they can heal. They just have to embrace the things that they fear the most, which are fear and pain. You know, so the mantra I came up with is train the brain with pain. For me, that's what I worked. And fear, if you have to use fear. And I can explain how that one worked. Anyway, that was all just to be able to get us to this point where we can see this stuff here. So I hope you didn't mind indulging me on that. Let's zoom in on this, because this is really a spectacular region. Holy cow. Look at how beautiful this is, guys. I mean, we have captured 60 frames here, and we're going to save this. Yeah, this is the benefit of stacking frames together, making image sandwiches. The more you add, the better it looks. You see detail you didn't expect to see. You know? Like these stars in the horsehead are extremely visible now. Oh, I love this. This right here is a picture alone. And then you just drag yourself up to the flame. Okay. And then the flame is a picture of this amazement every time you look at it. Wow. All right, we're going to auto mode this one. Okay, there you go. Now you might notice these things along the bottom here. This is the tracking. It's tracking. And as it tracks, we lose a little bit from one side. So it's tracking in the north-south direction more than the east-west. You know, we see a slight line over here, but we see more here. So what this tells me is a couple things. I could actually alter the way I'm tracking, or I could just leave it alone because it works. All right, let's go back to here and redock. Remember, guys, enter your numbers. If you're members of SkyTour Livestream, you can enter a number between 1 and 1,000 to become members. It's very simple. Just go to YouTube, look up SkyTour Livestream with Mark D'Antonio, and hit the subscribe button. Then hit the bell, drop down the little drop-down list. That's the bell, and say all notifications. Then you'll know when we go live. Because we stream to so many platforms at once, I can no longer just set up a YouTube stream and go on the YouTube stream and people know it's coming, so you can sit there and wait. It's unfortunately, it happens right away. It happens as we stream is when the announcements go out. Unfortunate, but that's the way it works. I try to make announcements ahead of time on the platforms, letting everybody know. Okay. So there we go. So let's go find something new to look at. Oh, I know. Maybe this. This is now more than high enough for us to see. This is the Orion Nebula. This nebula is the unparalleled king or queen of the night. Okay? And its source of illumination comes from these four bright stars, primarily in the center, but those are actually just part of the process. There are a number of other stars in there that help to illuminate the Orion Nebula. But never mind that. Let's just go see what he's talking about, shall we? Cindy Murphy has entered 360 for her number. Calybos and Tiffany, for you to mark that down. If I missed your number, Calybos is not, I promise you. Okay, let's see here. All right. There we go, off to the Orion Nebula, the Great Nebula in Orion. And there it is. Look at that nebula. It looks beautiful. Anytime you see it, it looks beautiful. And then this nebula up here is the Running Man Nebula. That is a really cool nebula. We're going to just travel east a little bit here. Okay. There we go. Now we're going to do a two-pronged thing here. We're going to take a picture here, and you got to bear with me. We're going to take a picture where the nebula, the Running Man Nebula, is more of the target, and then we're going to go down and do another picture down below to get the entire region, and then we're going to make a mosaic out of it, so you'll have a mosaic you can look at too. So this will be good. You'll see this. What I'm going to do now is I'm going to drop down our enhancement here, because I want to zoom in on this section right here of our image. And right down there you see 4 stars in here. These 4 stars are among other stars down in here that are illuminating, causing this to glow. You notice there's a green color, and you'll notice that there's a red color. The red color is visible when we actually do some more processing here. Okay, that green color in the middle and here on the outside, that is oxygen 3. What's oxygen 3? It's doubly ionized oxygen. Now, why isn't it oxygen 2? Why is it doubly ionized as 2? Why not oxygen 2? What's the problem? Because oxygen 1 is the ground state where oxygen has all of its electrons on it. Okay, and if you knock off an electron, all right, now it can't be oxygen 0. All right, so what is it? Okay, when you actually knock an electron off of oxygen, all right, it's called oxygen 2. The ground state is oxygen 1. All right, if you knock 2 electrons off the oxygen atom, it's called oxygen 3. So not the ground state, not the singly ionized state, but the doubly ionized state. That's 1, 2, 3. So it's oxygen 3. We signify the 3 with Roman numeral 3, O3. Okay. Stacy Johnson says 789. Nice to see you, Stacy. Please make sure that you subscribe and are a member. I'd love to see that. Guests get entered in. Okay. So the red, of course, is the hydrogen gas that we've been talking about before. Okay. And now what we're going to do is we're going to start a 30-second exposure on this. We are guiding. Here we go. And we'll live stack it. Yeah, that's the area of the horse head. Clear that. Get rid of our stuff over here. Renee Barnett's asking if she's disqualified. What did you do, Renee? Wow, look at that. Hello there, Science Bob. Nice to see you. Science Bob said 307. Curtis, I have not heard about Kerr's paper. I mean, as far as the singularity concept anyway, I'm pretty sure that there's no cosmologist anywhere that thinks that black holes actually have singularities, infinitely small points that all the mass is in. It's just a mathematical, well, you know this, Curtis. It's just a mathematical convenience. It's like when we calculate the, and this is for everybody else because I know Curtis knows this. We calculate the force of gravity between, say, the Earth and the Moon. We calculate it as if we're looking at the center of the Earth, where the force is centered, and the center of the Moon, where its gravitational force is centered. So we use the center of objects to calculate gravitational forces. And when we do that with black holes, it's the same thing. We do the same exact process, and we calculate it as if it's from the center. And that leads to the concept of having a singularity. But in reality, no one actually thinks there's a singularity there. Master Player asks, can you only enter once? Per contest, yes. But every time there's a giveaway, you can enter one time. Yep. But tonight, if you haven't entered a number, then you can. But once you enter it, that's your selection, and that won't be something that you end up being able to take back. So consider it carefully. Okay. All right, so I'm communicating with Calybos and Tiffany right now, and Marianne is also in there. And we're talking about the contest tonight. I got to say, there are no other sites that give away equipment like this. I mean, not with this kind of frequency. I mean, thanks to Calybos and Tiffany partnering with us and doing this. And by the way, they are officially volunteers for SkyTour Livestream now. We have given away 2 pieces of equipment so far, and we're going to be giving away a third tonight. And then moving forward, we're going to then give away, it may not be the next one, but somewhere along the line, we're going to give away an Aurora Sport, which is a night vision system. It has like 800,000 ISO. It's full color, and it's really stunning. Now, if you win a pair of binoculars, it doesn't mean you can't win the Aurora Sport the very next time if we offered it. Okay, it's as if you never entered the next time you play. Okay, Jessica S is here. How are you, Jessica? Namaste, Etsaman says, been following going on the big screen. Nice. First time on PC chat. Nice to have found a cool community. Grateful for all of you. Much love. Great work. Fun stuff. Gracias. You know what, Namaste, I have to tell you, we have a great community here. Everybody here wants to learn. And if somebody swoops in and does stupid stuff and puts stupid things up there, porn, all that kind, and that happened a few times. The bots come in and do that stuff. We rip them out. In fact, I don't even have to raise a hand. Our wonderful moderators here just rip them out of here in no time. And they're very, very good about that, because they want this to be an amazing experience for everybody, as do I. Let me tell you in the beginning, SkyTour Livestream first started as an actual little 8-foot domed observatory in my front yard, 75 feet out there from where I'm sitting. And I had to be in there, and to get the gear to make the broadcast was one thing. I had to get a wireless microphone so I could talk to people, and then I had to operate the telescope at the same time in the dome, because I couldn't be in the house. I didn't know how to do that yet. And then winter came, and there was one night it was like 10 below zero, and I was in the dome streaming, and I was literally chattering. I had those chemical hand warmers, warmers in my pockets, warmers in my shoes, and only the top of my shoes were warm. Only where my hands were, everything was on the back. were warm. The fingertips were frozen. In the pockets, I put my hands in my pockets to warm them up, and I would just squeeze the chemical warmers. And it was really very, very difficult. Very difficult. However, that gave me the impetus to look into doing it remotely. So the next step was to figure out how to connect to the telescope in some fashion. So the first thing I tried was Wi-Fi. It worked great. I bought a little Wi-Fi unit, and from the house I could connect to the Wi-Fi. However, I could only run it through my iPad. I couldn't run it through my PC. I needed to run it through the PC because that gave me the most possible opportunity and flexibility. So then I went from running it through Wi-Fi to figuring out how to connect through a cloud to my observatory out on the front lawn. And so I ended up connecting to the cloud service and then to the telescope on the front lawn. And that became the main mechanism by which I connected to the observatory moving forward. So it was pretty cool. So that was pretty much how it all happened, and I'm really not giving a whole lot of detail about that, only because in the interest of time, you know. Plus, like with the Casper Nebula, you see this amazing, brownish red dust here, and you see this blue reflection nebula, and then you see this inside. Well, that's an emission nebula. It's an emission nebula like the Orion Nebula that we just saw down here, and this is an emission nebula right here, this part right here, and it's red. It's reddish pink, isn't it? Right? So this isn't reddish pink, it's magenta. Why is that happening? This is the example, by the way, of moving forward. We're going to do astronomical questions that you can't readily look up on Wikipedia really quick. But you have to be able to critically think to figure out why this is magenta in color and why this is blue. And that is a Mission Nebula right there. And so is this. Why are they a different color? So that would be the question. And that's the kind of thing that would win you a telescope or binoculars or a Aurora Sport. Moving forward, we're thinking we're going to come up with some really, really interesting questions for you guys, the chatters, the attendees. Now, I'm going to give you this answer because I thought maybe it would be helpful to just give you an idea of what kind of stuff we're going to... it's the kind of thing that actually we would actually ask, okay? So, as an example, this nebula right here is indeed a red nebula. But it looks blue for another reason, okay? I'm sorry, it looks magenta for another reason. It looks magenta because you're seeing an emission nebula as seen through a blue reflection nebula. And in physics, when you have blue light and red light together, they will form a magenta light. Okay? So it has to do with the density of the nebula versus the density of the emission nebula. And that's what we're seeing here. We're seeing a color illusion based on the fact that there's blue reflection nebula also in here, where it looks like just a stark crossover to hydrogen alpha, or the red nebula, the red ionized hydrogen. So that's why this looks a little magenta to you. Okay? So that's the kind of expectation for some of the questions we may have for contests in the future. So it would be pretty cool. And hopefully you guys will you'll get a good kick out of that. And I don't mean a kick in the pants, a kick. Okay, we've got 16 here. We lost some because of wind So we lost a couple, but they were very close. Okay, we lost 4 in our overall. There we go. 1, 2, 3, 4 lost overall. The rest are all good. I'm just reading some chat now, just to see who's commenting. Sorry if I'm missing some things too, by the way. I really like, comments by Eric, who says, I'm surprised I have only recently found this channel. I watch space videos all the time. Never seen this channel until last week. Fantastic. It means it got on your radar somehow. We like that. Yeah. Now, do you see how this is looking so much better? I mean, look at that unbelievable cloud. We see this gorgeous reddish emission nebula up there and brown dust mix in. Okay, and then this here. This is by far more detailed than we've ever seen because this camera is capable of picking it up. Also, in case, if you're interested in knowing what I do, you can go to History Channel. Actually, a lot of networks, but go to History Channel, and the current TV show that I'm in is called The Proof is Out There. And I give my commentary on extraterrestrial life and UFOs in my capacity as the Mutual UFO Network's chief photo and video analyst. We will. We just filmed a whole set of stories. It was the 3rd visit to do a whole bunch of 10 or 12 stories, and they're going to come out a 4th time to do another 10 or 12 stories. And it's not stopping there. There's just so many more things going on. So the proof is out there on History Channel. Yep. And the nice thing is, I don't want to be associated with shows that take science and throw it by the wayside. I won't do it. And as it turned out, Proof is Out There is one of those few shows where if I say it's not a UFO because it's a natural object and here's what that is, they will get other opinions. And if my opinion was right, they'll say, yep, well, our experts have determined that this is actually a bird or this is a strange atmospheric phenomenon, So there's pretty cool, stuff. I just won't compromise the science. I did that. I didn't do it. I was kind of railroaded into it on a show that promised they would just let me showcase the science. And then when it came to showcasing the science, I mean, I literally here in my effects studio, I recreated lunar dust, lunar soil, minus the silicates that could cause you to get silicosis and die. Okay, so I left the dangerous particles out, but I had the material, it's there now, which acts just like lunar dust, moon dust. And we used it for compaction studies and so how it compacts and so forth. And I illustrated some of the features of the moon dust, and that's exactly what they asked me to do. And the guy that was here said, yeah, that ain't going to make it into the show. Okay, fine. Well, so then when the show came around, the producer was always like, "Oh, you're the guy. You are the main science guy. You tell us all the stuff that isn't real and that is real. I just love it." And when it came to the show, they seemed to kind of put words in my mouth, and I did not like that at all. And wouldn't you know it, when it was on Netflix, the little thumbnail for it was me in a computer. It's like, I didn't want to be part of that show. I didn't want to be noticed anymore. I wasn't happy with it. Look at this, guys. Here, we're gonna do what we did before. Let's get this out of here, and let us just go full screen. Oh, look at that! Wow. Just imagine, in a spacecraft heading in to the Running Man Nebula. Put on your UV shielding because you're going to need it. There we go. Wow. There we are. We're inside there now. Look at that. Wow. You can see individual pixels now. See the little tiny squares? That's how many pixels we've got here. So we pull out now the Running Man. You'll notice, if we look down here now, these look just like clouds. And the reason they do is because they are. They're clouds of dust, interstellar dust. This cloud is probably 3 light years across. Okay. This cloud here is probably 15 or more light years across. And the gossamer tendrils are, amazing. Now, here's the thing about this. You get in your spaceship and you head out there. When you get into the middle of this region right here, what do you notice? You just notice that you still see some stars, but you don't see these structures. You don't see any of this. These are so large that you wouldn't see them. This distance here is probably, like a couple light years here in size. And we just couldn't possibly fathom that, So we're seeing large-scale structures from a very, very large distance. But look at that. That's incredible. Now I'm going to show you something else. You see these horizontal streaks down here? As opposed to these horizontal streaks down here? Okay. Let me just zoom it like this for now. Okay, these horizontal streaks right here, those are the ones from guiding. But these horizontal streaks, you know what those are? Satellites. But not just any satellites. These are, and this is another question, what would these streaks be precisely? That would be another question. Okay? And I'll give you the answer to that one. All right? There's just an endless supply of them. Good evening, Bonnie. That's Anahata 77. But the answer to this question is, what are these streaks? When I say they're satellites, not just any satellites. These are geosynchronous satellites. Satellites that are 22,500 miles out in orbit around the Earth. And they're at such a distance. Why is that distance? Because that way the satellite stays over the same physical spot on the Earth as the Earth rotates. Now, why do we see streaks then? Why don't we just see a spot? Because we're following these stars. And the stars are rotating out from under us. The satellites are staying in that one spot. But as the Earth rotates, they're dragging out a little line. And so, over time, we see these amazing streaks in the sky, geosynchronous satellites. Pretty amazing. But look at the beauty of this image. Oh, gosh. What a stunning image. Let's go back here. Let's just zoom in again. Okay, we've done 33 stacked. Look at that. That's really pretty. Let's see if... let's actually bring it back docked for now. And let's see if we can kind of kick out some of the noise. Yeah, look at that. Wow. Isn't that gorgeous? Isn't that just beautiful? It's like a cosmic tapestry of color. It's absolutely amazing. Yes, the telescope is following the stars, so it's slowly rotating. Correct. Absolutely correct. So if we bring the telescope back here for a second and you look at it, you can see that it is pointing there, but it was pointing a little bit, toward the distance a little earlier. Now it's pointing a little more like that, a little more upright toward the south, because it's following Orion as it makes its way around the sky. It is super precise. That is correct. Folks, remember, we are running a contest tonight for the Celestron Cometron 7x50 binoculars. And all you have to do to win is enter a number between 1 and 1,000. And what I would like you to do is make sure that you're a subscriber. If you're not a subscriber, you can't win. So I'm hoping that you will, for all of you that are new here, please subscribe. I mean, you don't get this anywhere else. I feel like a National Public Radio telethon. But I'm not asking you to call in with your donations. I'm just asking you to click the subscribe button. No one's doing this. No one sees the universe live in real time. We're doing that. We've seen some fascinating stuff. We saw some strange UFO object in the sky on our AllSky camera. Our AllSky camera is this camera right here, showing you the AllSky. There's Orion, which is currently where we're looking. We're looking right there at the Orion Nebula at this location. Right, in fact, and then, so we've seen some strange objects there. And we were looking at the moon one night during a amazing eclipse of the moon. The moon was blood red. And at the height of the eclipse, all of a sudden, and we were one of 6 groups on the planet to see it, we watched a meteor hit the moon live. And it's in one of our streams. So you can look up the meteor strikes the moon in SkyTour live stream. And we give the time, and you can actually watch it happen. It's a white flash that occurs for a split second. Pretty cool. All right. Very cool. All right, we got one more save here. So 36 shots. That'll be our target for the next shot. And we're going to save exactly as seen. All right. So now we're going to zoom out now. And we'll go to auto mode. So there's the bottom of our field. So what we're going to do now is we're going to put Orion here. Well, I'm going to move it up to make the top of our field here. And then we'll capture stuff down below. And then you'll see this whole picture of what's going on here. It's absolutely astonishing how colorful, how deep, and how amazing this is here. So we've saved this, and it'll be up on the site here in just a short time. A few seconds. Now we'll go here. And there. And now we'll move ourselves down. And we're doing this live in real time, guys. Universe live in real time. Gotta admit, it's a lot of fun. Never, ever knew that it could be done. I never expected I could do it. Because I didn't know what was involved. So I started researching it, and I was determined to do it. And the next thing I know, I've found that I have a capability. Pretty amazing. I'm just going to drop us back down. Now, if you look over here, after we stop, right there, do you see that guy? That is a geosynchronous satellite, and it's moving right here. There it is. There you go. So we're rotating out from underneath it with the stars. So we're following the stars. If I turn off the tracking and the stars start drifting, let's do that. Let me come out of here. Okay, see that guy right there? Now watch what happens. Okay, turn off tracking. Okay, tracking is off. And look at that. See that? It's staying. And now the stars are leaving because we're now turned off tracking. We're on the Earth now, not moving the telescope to follow the stars. And now you actually see this geosynchronous satellite staying right there in the same spot over the Earth. Isn't that amazing? So you get to see physics, astronomy, all in action. And it's practical. Right there, practical learning. Turn back on the tracking and watch what happens. We start tracking the nebula again. And there goes our satellite. Because now we're moving the telescope slowly. But that's how much the Earth is moving right out from under us. We don't see it, but there you go. Now you see it. Anyway, so there you go. So I'm going to move this back now. I'll move it back, go back to the west a little bit. There we are. One more click. All right. There we go. All right. So we'll let this see it says searching. When it has a guide star, it'll start guiding. There we go. And now, same thing. 30 seconds. And process bar or progress bar right there. Going on and on. Bring back our live stack. Let's see how close I was. I got to get rid of this. Okay. All right, and now we'll see the first exposure of the southern Orion complex, and you're going to see all kinds of tentacles, effectively tendrils from Orion. Look at that. There's one of those satellites again. Look at that. Color correct this. And you'll notice you already see some amazing brown dust in just one 20-second or 30-second shot. Look at this very, very delicate gossamer stuff up there. That's just incredible. Let's do that. And that's the black level. There are those satellites I talked about. All right, we're going to do this. And then we'll come back here. Let's not zoom because... wait, do that. And turn off the zoom. There we go, so I can grab it. All right, here we are. Now, so you can see how much dust is here. Actually, if I pull it in, remember we're using more data under this curve. We're getting all this data now under the yellow curve. And there you can see there's a lot. I mean, this is just full of dust. Full of dust. So here's a question for you. And this would be another question. And as I said, there's many questions that could be asked. When you look at this dark dust in the universe, there seems to be a lot of it. What's the actual percentage of this dark dust in the universe? Do you know? I mean, whenever we do a SkyTour live stream, we see it everywhere. I'm not going to give you this answer. Okay? I know the answer. I probably talked about it in a Facebook post, so that might give you the clue. But the dark dust is a certain amount in the universe, and what is that number by our best estimates? You won't win anything tonight with that answer, but we're gonna do more than just equipment giveaways too. We're gonna do some giveaways of SkyTour Livestream T-shirts probably, and some other things too, for quiz questions and so forth. Happy to do that. You'll love our T-shirts. Oh my gosh, they're so soft. You have to understand, we're just getting our feet into this stuff, you know. I mean, no, we've perfected this. What you see here, no, we've perfected this. Okay? But as far as the experience of an Etsy store and the other things that we do, the giveaways, kind of new to us, you know. All stuff I wanted to do because I wanted to get people excited about astronomy. Calybos, same way. Tiffany, same way. Marianne, same way. Tara, same way. Daryl, same way. Okay, and all of you that are here night after night after night, same way. Let's look at Earth Radio. Okay, Ronald. Ronald's been one of our staunch supporters for years. And, you know, he actually supports us in a variety of ways that are extremely valuable to us. And they literally are making sure that we can bring all of this to you. So there's a lot to be said for the Sky Tour family, you guys out there. So again, please subscribe. I'm at 8,112 subscribers. I want to be 10,000 in a week. I mean, that's crazy, I know, but it's possible. It's possible. This is really a beautiful image. So we talked about this color here, this greenish blue, right? Now some of you said teal. I saw that in the chat. It is a green, and the green is the doubly ionized oxygen, okay, O3 with Roman numeral 3. And this red is the hydrogen alpha, or the ionized hydrogen that we call it. And if we zoom in on this region right here, you can see these large-scale features in the universe, these dust clouds. These dust clouds right here, these are going to be like, you know, a couple light years in size. A couple light years. We can't even go 4 light years to Alpha Centauri in less than 10 or 12,000 years. The fastest speed we can go. Now, my lectures that I'm giving around the country on advanced propulsion show ways to do that in a much shorter amount of time. But that right there is something that is unproven, untestable, but is within the realm of possible physics, and that's the thing that's very important. I want to point out something with this cloud right here. I just want to show it to you. Okay, remember we talked about density of the clouds? Check out this dust cloud right here, this oxygen 3 emission nebula as well. There's O3 in here, maybe some dust down in here. But you see that? Notice that it's not dense enough to hide the hydrogen emission behind it. You see that? So we see how they work together, right? But this is like an oxygen 3 emission. It's a very different beastie, you know? And it's not dense enough to cause any color interactions with this hydrogen here. But it's interesting how that shows. But that's a very interesting location in the Orion Nebula. Also in the Orion Nebula, we see locations where stars are being formed in the dark. Okay, deep in the dark here, inside these are not voids. These are dark nebulae in here. This is, again, part of the Orion molecular cloud complex. And deep in these dark areas here, there are, as we have found out, stars being formed, and in some wildly crazy, amazing, surprising cases, we actually have planets that have been formed without their stars around them. Just planets, rogue planets. Rogue planets. Isn't that crazy? Django, what's up? Good to see you. Yeah, really cool. Wow. So yeah, so this is just a beautiful and extensive nebula. Again, the satellites there. We'll work those out. We'll get rid of those. See, now the nebulas are beautiful, but for me, the most excitement is down in the dark dust. That's where it's all at. That's where life is being made, is in that dark dust. Hey, Goblin, thank you. Did you subscribe? Let me know. And also, make sure that we have a way of connecting with you so we can let you know about the outcome of the contest, okay? Same thing for everybody out there. $11:30. It's 12:30 on the East Coast. I'm on the East Coast. Where are you located, Goblin? Yeah, it was great to see you, Goblin. So thanks a lot. And make sure you subscribe, okay? If you haven't. Look at these dusty clouds. Wow. Yeah. James Hyde's right. You're talking about Central Time. Oh, you're in Alabama? Okay. All right. Well, it's 12:30 here. Vincent's Virtues. Hey. Sometimes I look up at Orion and think I can vaguely see something under the belt. No, you're exactly right. What you're looking at right here on our screen is that thing. We've been taking pictures of that for the last half hour. So yes, that's right. You can see it. Vincent, did you enter a guess between 1 and 1,000 to win the Celestron binoculars? Genghis asked a question. We're going to answer that in a minute. Vincent, I believe you know Renee. Okay, Mr. Django says 357. That's a Magnum, but yeah. Excellent. It's good to see you, man. I know she told me you might that you like astronomy a lot, and so that's what I went to school for. And as you can see, there are many reasons why. Just look around, right? It's really pretty out there. Hang on, guys. I'm just gonna change it. I just changed the temperature on the heater because I need a heater in here. It's cold in the bunker. Ray Bobel, hey there, how you doing? Nice to see you. That is so cool to see you, man. Raymond has been another very solid supporter of SkyTour Livestream. I want to thank you publicly for that too. Yep. Yeah, Vincent, a number between 1 and 1,000. If you haven't subscribed, do so, because you have to be a subscriber to play in this game. And we give away equipment, man. Okay, he chooses 420, okay. Calybos and Tiffany, you'll note that. I think Goblin went to bed, Marianne. But you're still here, that's good. Look at this beautiful image. Holy cow. Oh, there he is. So you subscribed, and that's good, Goblin. I'm glad you subscribed. I want to see everybody who's new here to, please do subscribe. We do this like no one else does this. I don't know why. I just don't know why it's not more popular. I just don't. I mean, maybe people don't want to learn astronomy. I would hope they do. Yeah, I think C&D Boy is correct. And I would like to announce the winner of the contest. There has been a winner. Would you okay. Okay, yep. Calybos announced it. The winner is the Goblin, who just saw this channel for the first time. Well, guess what? You're walking away with a beautiful pair of Celestron binoculars, man. So, that's all you, man. So, I hope he's still here. I'm waiting to see the Goblin say something here. And we're still capturing images here. We got to go a few more. Come on, the Goblin, where are you? Show us you're still here. Because you won, man. You actually got the exact number, 888. He is here, yeah. There you go. Great, brother. Thank you so much. I'm glad that you played. Not bad for your first trip to a stream, huh? That's what we're all about. That's what we're all about, man. All right, here's what you do. Okay, Goblin, this is for you. You go up there to skytourlive.org, okay? And you'll find a contact us up there. I want you to write your name and your address and where we're going to send these binoculars, okay? And we'll take care of it. We'll get that. We'll take it from there. So it'll be a post-Christmas gift to you from Sky Tour Livestream, Calybos and Tiffany. Right, so what you do, like I said, go to skytourlive.org and go to our contact form. All right? And just write us. Trust me, we get the messages. Very cool. And Calybos, I'm glad you chose to announce the winner because Goblin was heading to bed, and I sort of knew that he was close. All right, once again, up here, skytourlive.com, right up here. All right, I'll show you. Go to skytourlive.com or skytourlive.org, either one, and you'll see up in the menu, you see a contact, okay? Contact us, all right? Leave us a message, okay? And you'll be able to connect. All right, now our email as well that you're going to be writing to, I'm going to put in the chat as well so you can see it. And if any of you have questions, you can also contact us as well. Okay, here you go. Okay, that's our contact email. If you guys, like I said, if you have questions, you can feel free to do that. Curtis, thank you for putting up the website. And don't leave your address in the chat, but just go to contactskytour@gmail.com as I put in the chat and leave us that information. And we'll get your binoculars right off to you. Yeah, we have a very happy viewer who also had just found us, and she won the binoculars the last time, and it was really quite nice to see that. I like it when we can do something cool for someone who just found us. It's like, wow, I won something? I only saw it one time. Yeah. So, it's crazy fun. It's awesome that you did it. and we congratulate you, man. You know, so you're in Alabama. I'm going to be speaking in Arkansas in April at the Ozark Mountain UFO conference, and can't seem to connect to the link. He says it's is that the link that well, the email is contactskytour@gmail.com. So just use that. The link works. Wow, look at that. It's actually going to be freezing in Wickenburg, the nearest town to us. All right. So we're up to 23 images here. This looks really nice. And that's really all we have to do. We don't have to do a whole lot more. We'll do 24. Very cool. James Hyde says, where are you going to be? I'm going to be, I'll be landing in Fayetteville, but then I'm going to go out to Eureka Springs, where the conference is being held. I'll be doing a talk about the physics concept that allows for alien craft to literally be deep under our water, be in one place in the universe, and then relatively instantly be in another place in the universe. It's really distantly plausible physics. Depends on string theory, but it's something that I believe is very possible. And to Goblin, don't worry if for some reason you can't connect with us. We won't move on. We'll make sure you get your binoculars. Okay. I'm gonna save this now with 25. Save exactly as seen. Okay. All right. So that's a beautiful region of space there. What we're going to do now is go back to our Finder and check it out, and then move on to another object. Let's go to 25%. Okay, so let's go back to here. And by now, we should be able to get to one of the most beautiful, amazing regions in the entire sky. Seagull is still not high enough for us yet. Maybe it is. Let's look at... Yeah, not yet. Okay. The seagull's beautiful, but the one that takes the cake is this one here. And last time we photographed it was with the new moon, and the full moon nearly. So it was tough to really see a lot of the detail. But you're going to see it now, and you're going to go, wow, look at this thing. So as you move, you're going to see a cluster show up. Here it is. Okay, cluster of stars. You see something faint around this here. This is neat. Okay. Oh. Okay. So what I'm going to do now is move us a little bit eastward. Here we go. Okay. And I know you don't see much right now, but just wait, because what you see right here is something absolutely astonishing. This is typically the most beautiful nebula that people will see besides the Orion Nebula. This one is the next most interesting stellar nursery, the birthplace of stars. So I'm going to put it right here. There we go. Mr. Django, thank you for coming, and let's hope things overseas with you are going well. And we will see you soon enough, I hope. So we'll see you. Eric, heading to bed? Yeah, that's right. Goblin is all excited about getting his binoculars now, so he probably can't sleep. Hey, look, I love that. I like seeing people get excited about this stuff. So does Mike, who is Calybos and Tiffany. We all do. All of us in SkyTour do. Okay. I am going to set up a 25-second shot and go off and do it. And we're going to get a beautiful image. This is a star cluster, a young, hot star cluster. All right. Now, this image here that comes up, I'm going to be getting rid of. Okay. The young hot star cluster is interesting because it's within a beautiful, dense nebula. But look what it's done. Ready? Here it comes. Okay, if this one comes in, there we go. Look at that. This is an immediate one that we immediately go full screen on because we want to show you everything. So let's move that out of the way. Look at this. Okay, this is called the Rosette Nebula. And if you look at it, you'll notice there's a young hot cluster here, right? But the stars have done something pretty amazing. The stars have carved out this hole in the middle. Now, that's not really a hole. That's a spherical cavity in the middle here. And this spherical cavity was carved out by the intense radiation of these hot young stars, pushing out gas, so that if you have some nebula in there, it's getting pushed away. If you have some dark dust is a whole lot heavier, and that dark dust is being pushed away as well, but slower because it's more mass, has a lot more mass to it. So that's pretty cool. So as we watch this image come in, you're going to see some features start to appear that are just amazing, and we will zoom into them to see them. You can already see some beautiful dark tendrils of nebula over here. You can see this cavity forming around these hot stars, and these hot stars are also are already doing the ionization of the hydrogen gas in here. All right, and so we see that happening. There's also a mixture of this dark dust in here as well. Look. Now this region here is surrounded by dark dust as well. And because there's a nebula here, this nebula has illuminated through ionization the area surrounding it. So we see that a lot. Now, in this particular area, there's a lot of dark dust in the area. In other areas, there isn't. Okay? Over in Orion, we have the Orion Molecular Cloud Complex. And the Rosette Nebula is a little bit east of that, but it might be related to the Molecular Cloud Complex as well. Yeah. Is she talking about this Y shape right here? Right up there? Yeah, it's the flux capacitor. There you go. Oh, thanks, Raymond. You're welcome for the rosette. It's going to get much better than this. It's getting better. I'm going to color correct it first. Our curves are a little off. Okay. And then I'm going to... Thank you, Ray. Thank you so much. You know, when someone's moved to do that, it means that they really feel that this is incredible. And it is just crazy beautiful. Look at all that. Now, I'm really... This is called a push when you move these two curves close to each other. It's a push, so we're really pushing it. But again, this is live in real time. Universe live in real time. Jessica S says, one of my favorite nebulas. It is, isn't it? It really is. Hey, Raymond, you should tell people about your crater plates you got from us. Okay, let's let this go where it wants to go. It's almost gaudy. All right, let's bring this up a little more. Yeah, once again, Raymond, thank you. Thank you very much for your continued support of us. Michael Heydrich, you're pretty funny, Michael. Oh my word, Mark, is this really happening or am I dreaming? Beautiful, awesome, wonderful, wow. I'm really happy with the performance of this system. It took us a long time to get here in terms of development and working out the process. But now that we're there, we can repeat it. And just so you guys know, we are definitely putting in a second telescope out there. And I'll be out there. I was hoping to get out there January, but it's probably going to be early February now. And I'm going to be investing some time looking at some other sites. And we're going to go to these different sites and see if it's worth putting in a telescope at these sites. And if it's good enough, if it's good, then we are putting one in. And we're going to be adding another telescope to the mix. And right behind me here on the East Coast, I have one that's supposed to go in this building out here. But with COVID, we couldn't build the building because wood became obscenely expensive. And it's a little better now. So we're going to do our best to try and try and actually build the building at some point soon. I know Cosmic Ray has offered to help us with the construction, and we may take him up on that. We'll see. And I do know that there's other ideas in play. But it's looking good. Let's go see what our full width half maximum limitations are with our filter. Look at that. We're getting all 7s. Alright, that's good. We're gonna drop this down now. Alright, that's good. So that way, knowing that these values are really well placed values. So this will allow us to be able to, oh gosh, I'm just taken aback by this. It's just so nice. Wow. I'm going to zoom in here because I'm going to show you a couple of features. Now that we've got this nebula here, let's zoom in. Okay, so here's the hot young cluster of stars, brand new stars. Okay, I say brand new. Been here for a few million years. Okay, so that hot cluster is spewing energy in all directions. Radiative energy is toward us, away from us, left, right, up and down, every compass direction. And as we move down here, you'll notice something really strange. You'll see these features here. See that? See that spiky thing? It's no mystery that it's pointing right at this cluster. Okay, then we move up here. See that spiky thing? It's no mystery that that's pointing at the cluster. Okay, there is a reason why these things happen this way. And the reason is because the radiation from the stars is determining the shape of this entire region. All right, so as we look at this region here, right, this here is a pillar. A pillar. What's a pillar, Mark? Well, if we close in on this pillar has an area of high density material up here, dust and gas in here, and the starlight is striking it, and it's trying to evaporate it like it has done so by clearing this cavity out here around it. But it can't do it because it's too dense. So what happens is it continues to push away and strip away the material around it, but the stuff right there and behind it directly on the lee side of this attack of killer starlight is protected. So in these pillars, it's not unexpected that we might find in these pillars star systems forming in this dark dust, and star systems with planets. Now what happens is this dark dust, if it's dense enough, it protects young burgeoning planets from the ultraviolet radiation that could otherwise sterilize them. And so when we look at a place like this, we could be looking at the fertile grounds of life, formation of life, inside the cold, dark clouds here, protected from the ultraviolet radiation. And the denser the dark dust, the better it is. So I think that's pretty cool. Raymond says he's on a 40-inch Sammy. Is that a Samsung television? That's cool. Yeah, we had a big storm here through C&D Boy and Ronald. Temperatures in the 30s outside. It's going to go up to the 50s, though, over the next couple days. So hopefully the 12 to 14 inches of snow we got will melt. Outrageous. Neat. 27 Celsius, man. That's pretty warm, James. James Dugan down in Australia. Winter for us is summer for them. Don't tell the flat Earth people that. And don't and James Dugan, don't tell them that Orion is upside down as seen from your location. Upside down Orion doesn't fit. Can't have that on a flat Earth. Yeah. Okay. All right. So we have captured now 26 stacked images here. Not bad. I'm going to do a little noise removal here. Back this out a little bit. Tad. Wow, this is really pretty. Now I'm going to take us up to the other side of the nebula, several light years away from where we just were, because I want to show you these curious little dots. These curious little dots are very interesting. These are areas that, remember I talked about that dense dark dust? These are areas where the dark dust has persisted and not been depleted by the starlight. So they have gravitationally condensed to form these globules. And the astronomer that discovered them was a man that I knew named Bart Bok. Bart J. Bok. They were called Bok globules. And I had the pleasure of being taught by Bart Bok for when he was visiting the university. A really cool guy. And the Bok globules are very important because this is what happens in a cloud of dark gas and a cloud of gas and dust like here. This is the dust, the dark stuff, and the gas is all around it and permeating throughout it. Okay, we have the hydrogen here, vast light years of hydrogen. Okay, well, in the dark dust, okay, if a gravitational focus is turned up in some way, and that can happen just by having a concentration of gas through shock waves or whatever, then as that gravitational force takes hold, particles come together. And now two particles will attract the third. The three particles attract the fourth. And it cascades until finally you end up with this dust focused in a concentrated location. And this focus is where you'll see denser and denser material. And the denser and denser it gets, the higher the probability that you're going to get something to happen there that's really interesting. Kinda like a star system forming in there, or a planetary system forming with a star system. And because it's a dense region of dark dust, it's protected from the ultraviolet radiation of the surrounding area. And so it might form a little cocoon of potential life-bearing planets. Really interesting. So we'll zoom back out here. Isn't that incredible? Let's zoom in over here. Look at the details in here. This is just incredible. And let's go up to the flux capacitor right near our Bok globules. This beautiful region here, again, it's in 3 dimensions, so we don't know whether it looks like this, like that, or however. This here could be shooting right toward us, or this could be shooting away from us, or right toward us, or some combination of all the others. That's crazy. Just incredible. Ronald at Earth Radio says, Mark, do all the objects we see make sounds? Interesting question. On Earth, sound travels through air. If you don't have a medium through which sound can travel, then you won't hear sound, right? So in the dead of interstellar space, it's soundless. Okay. However, depending on the density of a nebula, or in most stars, sound waves are very important things to study, because the sun has sound waves, because it's a dense area through which a wave can propagate, and that wave is again going to be a sound wave, as well as waves of light, of course, but you also get sound. And so when people say that the stars are roaring, they are. You're hearing the sound of all of this amazing set of processes going on inside a star. If you're in a dense nebula, then you might also get sound, although it has to be really dense. Stars are the most likely locations where you'll hear any sound coming from it. But you're not going to hear sound in a tenuous nebula like here. You won't hear sound there, but you'll hear it. You'll hear it elsewhere. You'll hear it in dense areas and in the stars. Let me see the chat. Let's see. Welcome, QW, and you're from Quebec. Nice to see you. Yep. And let's see. All right. Ronald says he was in Perth and Sydney in 1981. Well, I mean, those are on opposite sides, aren't they? Okay. I'm just catching up on the chat, guys. Genghis says, gorgeous. It is pretty. Let me see if we can punch out these colors here a little bit. That looks really nice. Look at that. This song is definitely waking me up. QW, thank you for joining us tonight. Make sure you subscribe. Would love it if you would. Join us. Okay. I'm going to say at this point we have stacked 41. And maybe 42. Let's see. Yeah, this is beautiful. This is going to make some really pretty imagery. Bring back the telescope. I know it's not going anywhere because I got a beautiful image here. Wow. Alright, so tonight with the Rosette, we talked about pillars and Bach globules. We talked about ionization of hydrogen gas, ionization of oxygen as well. We talked about the abundance of hydrogen in the universe, number one, the abundance of oxygen, number three, third most abundant. And we talked about sound from stars. If you were going to be inside the stars, they'd roar because it's a medium that can transmit sound waves. We talked about the pressures exerted on a gas and dust from young hot stars pushing outward with their stellar winds. They carve a cavity around the young hot cluster, and that's just what we see here. And to see that in its entirety, you back out. Now there's another Trifid style nebula known as a northern Trifid, and we'll have to see that as well. Not tonight though. Alright, well, I have reached the limits of my abilities tonight. I am tired, and I want to thank you guys for joining us. I hope you enjoyed this. Congratulations again to our winner, and I will check to see if the Goblin has sent us the information he has. So in that stated, I want to say thank you all for coming. I've really enjoyed your company tonight, and you guys are champions, man. And I do this for you. I do this for you. You know, I can do it alone, and I have done it alone. But you know what? It's no fun. And here's JSCO 77 right here. Okay, he was lurking. And D. Smith, I see you were too. Very nice to see you. JSCO won our telescope. He won it on Christmas. It was a Christmas giveaway. Speaking of Christmas. All right, guys. Well, you have a good night, and we will talk to you on the very next stream that we do. We're kind of averaging every other day, so we'll see what we can do. If there's really an especially important and intriguing object or event, we will be up there and we will stream. But so you can see me do it, I'm going to save this now and then save exactly as seen. All right, folks, you have a good night, and I will talk to you later. All right, so good night all. Thank you for coming, and again, keep coming back. We have more stuff to give away and more cool things to explore. Good night, everybody.